All right, folks, time to take your seats. As we begin, welcome to TLS Working Group at IETF 96. Let's see. You should probably all be familiar with Note Well. Here's a brief summary of it. If you don't, if this isn't familiar to you, it probably should be. But you can get more information at the links in the details section. All right. So today Sean's not able to make it. So I'm going to be sole chair here. So that'll be exciting. So we have Jabberscribe. Do we have a note taker? You good? All right. And the blue sheets are going around. Okay, so for agenda, we'll have a short document status update. Then we'll spend most of our time on TLS 1.3 topics. This will take as much time as we'll need for that. If there's time permitting, then we have a few additional topics to discuss. And if you're on the agenda for additional topics and you haven't sent slides to the chairs, please do so we can get them uploaded. So any questions or additions? Okay, so since last IETF, we've had one RFC published to the Cha-Cha Poly 1305 cipher suites. We have a couple documents in Auth 48. Cached info has had all approvals received, so that should be leaving Auth 48 momentarily, which is pretty exciting because that document's been around for a really long time. False start is waiting on FFDHE, and we're still waiting on DKG for the last questions, to answer last questions in the Auth 48 period. So awesome. That would be great. Then we have a couple documents that we've adopted, the ECDHE PSK suites, and a DANE document for DNSSEC, DANE record and DNSSEC authentication chain extension. So what's the main topics? Obviously, TLS 1.3 and our update to the ECC docs for TLS 1.2. And since the working group did not want to pursue the secure password draft, that's been set free so it can pursue independently, so it can be pursued independently of the working group. And there's been some discussion of LTS, but we haven't seen a lot of desire to pick that up as a work item at this point. I think right now we're very focused on 1.3 and hopefully we'll get that out soon. Okay, so I think now we'll go to, did you have a question, Jeroen, or something to add?
Yeah, I just forgot about the 4492 BIS. We have a new version of that came out a couple of weeks ago, and I don't know if it's ready for working with last call or not, but otherwise we really should decide if we want to have all the EDDSA there and wait for the that document to clear CFRG, or if we want to just publish it as it is.
Are there any CFRG folks in the room? So I guess the question is how far along is the EDDSA document? Is that momentarily, or is that still being worked on?
Kenny Patterson, CFRG co-chair. I think we're getting pretty close now. I think there's a couple of nits being found. There was some implementation recently, and a couple of questions came up about details in the spec, but we're pretty much there.
Okay. So I think we'll have to maybe wait and see a bit, but it might be worth waiting so we don't have to do it again. All right, so Ecker. You got that. And there's the pink box.
Oh, I'm so excited about that. Hate me on this side, okay. Right. Okay then. So we're now in draft 14. I'm hoping that we'll hit 20. There was some desire to stop at 13, but we just couldn't quite pull it off. There's actually been 2 drafts since last IETF. So here is a summary of the significant changes. Everything that asked for is something I'm actually going to hit. I got a slide on later, I think. So the big set of changes is that at the last IETF, we agreed to remove all the Diffie-Hellman zero round trip modes, both the ones that were Diffie-Hellman with no Kleinoth and the ones that had Kleinoth, and rely solely on the sort of pre-SK resumption for zero round trip. So this draft executes, 13 executed all of those changes. And we've verified they're like reasonably complete in the sense that we actually have 13 implementations that interrupt. So, there's still open questions, but that at least quasi works. The other big change is that we restructured the key schedule, which had gotten messy and had some now out-of-date assumptions about the order in which keys were known, and it turns out that keys are known in a very specific order, and so you can have a linear key schedule, and that makes things cleaner. The final big technical change was a request by Karthik Bhargavan and some other people to add sort of we're calling a resumption context to the key derivation, and the intention here is to sort of carry the session context through resumption into future connections, which I'll get to a little bit. Then we finally finished baking hello retry request, added these ticket flags for new session ticket, and a bunch of other sort of stuff you can just read in the screen, which I'm not going to bother to go through because it's just too boring, and you can read the draft. The only thing that I wanted to call out that is a significant change here that I guess nobody expected on the list, so I just did it, is traditionally TLS load handling is kind of a mess in the sense that that there are warning alerts and there are fatal alerts. And in principle, you're supposed to continue after a warning alert, but as a practical matter, implementation is typically just choke if you send them a warning alert. And also many implementations don't actually send the right alert to the right times. So basically what I did was I removed the support for alerts that are warning level alerts that don't mean I'm closing the connection now. So now all the warning level alerts mean I'm closing the connection. All alerts mean I'm closing the connection now, and warning level alerts mean I'm closing the connection and you can just tell the application that things were fine, and fatal level alerts mean I'm closing the connection and you should tell the application there's some kind of error. It also used to be the case that TLS at various levels of force told you that if you received a fatal alert, you're not supposed to resume the connection. That basically is not consistent at all with a session ticket style implementation of the TLS server. And so I softened that substantially so that basically it says, if you're keeping state like you're a client or you have session cache, then you should probably not read the connection. But if you're a ticket implementation, you can do whatever you want. We could soften that even further and remove the requirement entirely. There's, to the best of my knowledge, no technical reason for refusing to refusing to resume after a fatal alert. It's, I think, basically it's an abundance of caution, but it's also not a particularly difficult practice. One thing I forgot to put on my slides, so maybe we'll just, if you could just note that we hit this in the agenda. There was some debate about how forcefully we should require people to send alerts or not send alerts, and David Benjamin and David Garrett had some discussion on the list of that. So we had a discussion in a while back about how to handle this, but I never executed it. So I just want to make sure people are still okay with post-execution. Finally, at the end, I completely rewrote the security analysis section, which had been sort of sitting around since SSL version 3 and no longer reflected how the protocol actually worked. So the target of this section is to give you a largely informal view of what the properties the protocol is supposed to provide, and then provide citations to more formal definitions of what the protocol actually does, as well as citations to the known references of analysis that shows the protocol does not do the things that it claims to do. It would be great if people would read that and send me comments, especially people from CFRG. I'm looking at Kenny here, has already sent me talk to me verbally. So this is not intended to be like a scientific proof, but it's intended to give you enough pointers to references that you can understand what's going on. So I think I don't think that the handshake part, I'm not sure. I have a fair level of confidence about, because that's the part I understand the literature better. The symmetric part I'm less confident about, so I'm hoping we can get that cleaned up. Okay, next slide, please.
Just one question. I wanted to see if there's any concern in the room about any of the alert changes, since I don't think we talk about that any later. Just give people opportunity if they want to come to the mic now. Okay, thanks.
So I guess I might as well at this point summarize what I'm going to do in the future, which is we'd agreed back in the interim in Seattle that the rule would be that there are many conditions where that we told you had to fail the handshake, and it used to say you must send an alert, and there was a lot of sense that we should instead say is you must terminate the handshake, and if you send an alert, it better be this one, but not to require you to send the actual alert. I don't actually feel strongly at this, but this is what we agreed, so I'm planning to execute it unless somebody objects to that. Okay. So as I say, the sort of two major structural changes are really removing all the Diffie-Hellman based zero round trip stuff and nailing it to the resumption PSK and the key schedule. So those go together. We bounced around a little bit about what goes in this first flight, but what goes in this first flight now is the early data indicator saying that you would intend to send zero round trip data, a key share, a pre-shared key, which indicates the key you're actually going to use to encrypt the zero round trip data. The convention here is that the first one, if you send a list, because you might have multiples, the first one is the one you use to encrypt the zero round trip data. And then a Diffie-Hellman key share, which I suppose don't literally have to send, but you really are going to be very sad if you don't send, because first of all, you may be doing PSK DHE as the key exchange, in which case you need it. And also the server is at any time permitted to forget all its tickets and simply force you back into full handshake, and that means you would need a Diffie-Hellman share. So you'd be kind of silly enough to send that, though I suppose it's in some sense optional. I forgot to show it here, but you also send this ticket age extension, which was given to us by Martin Thompson and Cal Necritz, which basically indicates the time between the ticket was delivered to you and the current time. And the point of this is basically tightly bound the window of replay of these messages. So the structure here is basically that the server stores the time that he sent the ticket in the ticket. And then when the ticket comes back in, he pulls that time out, looks at the delta, the actual delta versus the claim delta, and if those are off by more than whatever slack he has, he rejects the zero TT data. This doesn't give you complete protection because you still have these sort of fragmentation attack that DKG identified back in Seattle, but it gives you protection against sending the same thing over and over again and having it constantly processed. If the client is not active. So the concern Kyle had raised was that you could just basically send zero RTT data even if the client wasn't on the net, and and it was already processed. And so this prevents that largely. Then you follow up by a finished message. Very important to note, you don't need to read this finished message in order to determine whether you're going to do 0RT. So everything you need to know about whether you're going to accept 0RT is in the client hello. The finished message just provides an integrity check over that, and I'll get to that more in a minute. This is important from an implementation perspective because it means that you can make all the important decisions about what you're going to do purely by reading the client hello and send the server hello right away, and then basically convert to reading the finish in the first flight rather than having to bounce back and forth between reading and writing. So if what you do is you read the client hello, you make all your negotiation decisions, including whether you're going to accept the 0-round-trip data, and then when you read the finished, if the finish doesn't verify, you support the connection because it's basically just toast. So this makes the implementation a lot easier. This is a change between 13 and 14. In 13, we had this ticket age and encrypted extensions between these 2 points, and it made the implementation quite a bit harder. Then you send then we go back to what we had before. You send the application data, if any. Why you would offer 0-round-trip data and not send application data, I have no idea. And then you send the end of early data indicating it's over. I think I mentioned this in the draft, but I'll mention it publicly now for people who are maybe thinking of implementing. When you build your stack, it's like super important that you don't wait for the end of early data before you send the server hello. And the reason is because you want the client to be able to keep sending data in this first flight until he's received the server hello, so you never have a deadlock condition of dead air on the network while each side's waiting for something. However, if you write your implementation, so you wait for the end of early data, so it's fine to wait for the finish, and you should wait for the finished. But if you wait for the end of early data, then you're going to have a deadlock because the clients which won't send end of early data until you receive server hello. So that's like if you find yourself deadlocking when you're doing 0-round-trip, that's probably what's happening. Okay, so this is mostly review. Next slide. The other big change is, as I said, we rationalized the key schedule. So the key schedule has sort of these weird ins and outs and loops and stuff because we're trying to handle the cases where sometimes you know one secret first and says, there's another secret first, but then Karthik and Antoine pointed out that and said, Rick, that actually it was the case that you knew the secrets in a very specific order and you can always assume that. And so we researched the key schedule pretty substantially, make it a lot simpler to work in. The basic idiom is that everything on the left side is pure entropy. So everything on the left side of the schedule, basically you start with you got to start with some initial value. There's basically a current secret, and every time you get a new piece of secret key material, you just mix it in with HKDF extract. And so at the very top, you start with a PSK if there is one, otherwise you have a 0. And you mix it in, you get this early secret, and then if you have a Diffie-Hellman share, you mix that in, otherwise you mix it to 0. And this last section, we have a pointer, don't we? Yeah, there we go. But I can stop gesturing that way, gesture a different way. So this last stage here is strictly speaking unnecessary, but what it's doing is it's separating the keys from separating the keys that are the handshake secret keys from the master secret, so that basically you can't backtrack between them. If you somehow have a compromise here, you can't backtrack back to the finished secret. It's not really clear if this is providing substantial security value. There's some contrived attacks that this kind of protects. If you get compromised halfway through the handshake. Like I say, it's contrived, but it's not a big deal. The other thing this does, which is actually more interesting, is if you ever had a key exchange where there was a final key which was known only after the handshake was partly complete, you could mix it in here. So if you were doing if you had, for instance, static Diffie-Hellman certificates and you wanted to mix in the Diffie-Hellman key at the very end, you could shove it in here. So that was the clinching argument for why I left this placeholder in here. It's also just one more crank of HKDF. So as I say, this is all just entropy on the left side. Then the right side basically is you take these base secrets and you basically mix in the transcript at any given time to produce sort of, I wouldn't call them working secrets. What they are is they're secrets that used to make working secrets. So the convention here is anything which is used as input key material is called a secret. Anything which is used to actually do HMAC or AAD is called a key. At least that's what I'm trying to do, though I may have failed. So the idea here is that to take this example, say you take the handshake secret, you mix in the client server hello with a log with some label, and this gives you the handshake traffic secret, and you use that to generate the keys that are actually used to encipher the handshake messages. Because obviously you need an AED key in each direction, nonce in each direction. So you only have to mix in the log once, and then all the key derivations basically don't take any context at all. They just basically take because they already have the context pre-mixed in. So that turns out, as I said, to make the implementations easier, because you can have a single input to the key derivation functions. It doesn't have to include the logs. It was easier for me, at least. I think it was easier for other people too. So let's see. That's pretty much it on that one. Next slide. So the final sort of key scheduling thing that went in here was Karthik Bhargavan had pointed out that the handshake when you do resumption, the handshake transcript of the first handshake, which is what includes the server identity, isn't always tightly bound into the subsequent handshakes. And so this particular lack of context is one of the sources of the issue that Scott and Vandermooy and Kremers, et cetera, found in the sort of initial drafts of post-handshake authentication about what was being signed. While that attack doesn't happen if you don't, unless you add features you don't already have, or we didn't already have, Karthik suggested it would be easier if you just added this context all the time, and then you'd be much safer about what you could do with the log. So the basic hack we did was take the resumption master secret and compute two values out of that. One is the PSK that you use for the next connection. The other is a context value, which you feed into the transcript logs. And so basically, anytime you do start the handshake hashes, you take both these values, and if you're not resuming this value, it's just hashed off as 0. David Benjamin asked, why are we hashing this second thing? I don't have a good reason for that. It was an aesthetic, perhaps mischoice. I don't want to spend a lot of time on this because we have a discussion later about whether we should change this in some way. So maybe I'll just hold on to that. But unless it's not clear. Next slide. I think we can skip this. Okay, so this is on the agenda as a real thing, but I think we actually got consensus that we had a really extended discussion at the last IETF and then at this Tron 2 post workshop about key separation for the messages that are sent after the handshake is complete, namely the application data messages versus the key update and any post handshake client authentication and the new session ticket. And so it looked like for a while we were going to have some very unpleasant choices about security provability versus implementation complexity versus analyzability from other perspectives, because the cryptographic security proofs worked a lot better if you had basically a separate key that you used to encrypt, say, the new session ticket versus the application data. But it made the implementations like really unpleasant, and we didn't have a really good way of marshalling it. And so we had this extended discussion on the list, and then Hugo Krawczyk produced some nice results that basically seemed to show that this key separation was very valuable in the handshake phase, but wasn't as valuable afterwards, and you get away without it. And so I think there was general consensus we could live, which is the existing design, which is to have one key at the very end. Hugo seemed okay with it. Doug Stabile seemed grudgingly okay with it. And I know that the people doing the symbolic analysis prefer it this way. So I think we had rough consensus to move this way. Very important, there'll still be key separation for the ordinary handshake messages versus the ordinary application name messages. So the handshake message is still encrypted with one key, and the application message is encrypted with another. It's merely the post-handshake messages which are encrypted with the same key.
So that's my impression too, is that there is consensus on the list for, at least rough consensus for this approach, but we should have some discussion now if people are not comfortable with this.
Yeah, so Martin Thompson, this is great because the complexity of the alternatives was horrible, and some of the privacy properties were also kind of shocking. You didn't mention that.
Sorry.
But this is specifically key update, new session ticket, and the post handshake auth for people who weren't following along.
Right.
New session ticket was the one that bothered me the most, but it seems like Hugo's happy, so I'm happy if Hugo's happy.
So is there anybody who feels this needs additional discussion? All right.
Okay, moving on. Okay, so first open issue, and I'm going to apologize in advance for like the fact that this showed up on the list so late. As we started to implement, we started to find that the cipher suite negotiation had become crufty, maybe the right word here. As everybody knows, TLS, when SSLv3 rolled out, there was exactly one control point for cipher suite negotiation, namely the cipher suite, and that indicated everything important about the connection. Unfortunately, it turns out there are parameters which you wish that had been able to indicate that didn't indicate, like for instance, which signature algorithms you'd be cromulent with in terms of hash function, hence 1.2, and B, or things like the curve types you supported, and B, it started to lead to, shall we say, a proliferation of code points. So it was already kind of hairy. If you go and look at a 1.2 implementation, you pick the cipher suite, which tells you ostensibly which signing algorithms you should be using, and then you look at signature algorithms, which tells you ostensibly which signing algorithms the other side would support, and somehow you have to pick a key which conforms to both of those. So that was already kind of aversive. The name group stuff made it worse for the same reason, because it was possible, like for instance, advertise elliptic curve Diffie-Hellman and then say I don't support any elliptic curve Diffie-Hellman groups, or and similarly, even though and now in 1.3 where we have the finite field groups and the Diffie-Hellman and the ECG groups in the same space, but it's possible to say I support Diffie-Hellman, I support finite field Diffie-Hellman, but then offer only elliptic curve Diffie-Hellman groups or vice versa. It was sort of clunky and orthogonal, and also you could only offer key shares in one group. And in 1.3 this gets worse, as I say, because of also the p shared key. So it was kind of nasty. And when we started to implement, it started to get very painful. And so I sort of like resisted any change here for a really long time, because I was like, we have something and it kind of works and it's going to be a big change our implementations. But finally, David Benjamin prevailed upon me to look at this, and Nick Sullivan. And so at least a bunch of us, me and David and Nick and Simode and Filippo and Martin Thompson and Richard Barnes, I sat down and took a look at this and have a proposal for how to clean this up in a way that we think makes life better. There have also been some almost grumbling, by the way, from other people how much this sucked, in specific of Laurie. I have a proposal here, which I apologize again for the lateness, is I think a substantial simplification, which I think we should look at adopting. So the basic idea is that rather than bundling everything up into a big cipher suite, to independently negotiate the things you already are quasi-independently negotiating anyway. So you basically have four orthogonal axes. You have the AED and the PRF, which we're gonna just, in order to keep our sanity tied together. So that means we have three separate AED PRF code points. We'd have AES GCM 128 and SHA-256. We'd have Cha-Cha Poly SHA-256. And then we have AES 256 SHA-384. The signature algorithms, namely the things that you would allow the the things that others I could sign with, which now post the change David Benjamin suggested about signature scheme also includes the elliptic curve groups we accept signatures in. So there's no way, so you don't have to worry about the interplay between name groups and ECDSA anymore. So we already made that change. And then the key shares and supported groups, which indicates which Diffie-Hellman modes you'd support. And this, of course, merges elliptic curve Diffie-Hellman and finite field Diffie-Hellman into the same box. You just treat them as Diffie-Hellman with different group sizes. And then the PSK itself. So breaking this up into four axes and negotiating them as separately as you possibly can, which is fairly separately, but not completely separately. This is actually incredibly straightforward for all the public key modes. And if we didn't have PSK, this would be like incredibly straightforward. PSK makes it somewhat more complicated, but it's not as complicated as you'd think. And I think certainly less complicated than it was when you had everything in one box. Yes, Martin.
Yeah, Martin Thompson. One thing that you should point out about the key shares name group things is, if at some point we want to do this post-quantum stuff, I know that that's happening in Chrome, we would define a new group, in inverted commas, that contained ECDHE parameters and whatever post-quantum parameters were necessary so that you would combine the two key exchanges, and it just looks like a single group.
Yeah, that seems like the most attractive design for that. Yeah. So you have like, New Hope plus 25519 as a single key share.
Right.
So good.
Hi, Subodh. So one thing I realized is one thing we lose by splitting it up. I just realized this, but lose by splitting it up is the prioritization of like which one is more important. So the cipher suites give us like this order of like this. This kind of is like the GCM, and then like SHA-256 is more important than this. So which one do we ratchet first? Do you have thoughts on that?
I don't think we do lose that. What we lose is the ability to talk about combinations in the same way. So, so each of these actually does provide a prioritized list, with the exception of PSK. So you can say I like this name group more than this name group or this name group, and you can say I like this signature algorithm more than this signature algorithm. What you can't say is so what you can't say is I would like curve 25519, but only with AES GCM, and don't give me curve 255 with cha-cha. And you can't. So A, you can't say it, and B, you can't prioritize it, right? So 1.2 allowed you to do that, and there are some edge cases where people did that. So probably the most is Russ Housley in the room. Forteza is an example of a case where you did that because you could only use Forteza with skipjack and KEA, with skipjack, KEA, and DSA. And Suite B is kind of an example of that, but the Suite B cipher suites are kind of a mess anyway. So in general, like the thing you lose isn't the ability to prioritize, the ability to express that you only set sparse points in the space. And that's the usual counter argument against these Chinese venue negotiation schemes, is you only can express the full space. Now that we've reduced the options so much, it's actually really hard to understand what the situation would be when you didn't have a full when you couldn't negotiate the full space. And so basically the situation, of course, would be the client wouldn't support some combination, and the way you deal with that if you're the client is you merely do not offer. You just can't offer the fully orthogonal space. You have to pick whatever horizontal works.
Yeah. So Martin Thompson, I know that we used to do this, but we used to have logic to select the group based on the symmetric cipher that was in play, and we would sort of set a minimum bar, and we'd look at the certificate and what key was in the certificate and a bunch of other things. I know when Eka showed me his implementation of this change, he removed all of that. It simplifies everything a great deal. But you can still do that. You can still decide that if you've chosen AES GCM 256, that 25519 is not acceptable, and you'd only support ED 448 or P384 in combination with that. That's a choice that the server can make. The client really doesn't have a lot of control over that. That's
correct. That's exactly the impact. So next slide. So if you just consider the public key side, this is like incredibly straightforward. The cipher suite just indicates the AED and PRF. We initially toyed with the notion of basically keeping all the existing cipher suites and basically saying that if you offer anything with AES GCM, that means you accept everything with AES GCM. That turned out not to, when I actually tried to write that down and implement that, did not work well. So probably it's actually better to simply define 3 new cipher suites, only defining those the PRFs, and just pun on that. It's a little hairy, but it'll work fine. Mine are cleverly named TLS _* with AES GCM 128 SHA. We can pick out the names. This is the added bonus, which I wasn't sure how I should disclose here, of allowing us to prune some of the cipher suites which you might or might not like so much, which somehow crept into our list because they still passed the AAD bar, even though they had symmetric ciphers, which we didn't actually love. Camellia, I'm looking at you. So since we have to define new cipher suites, this gives us the advantage of like only picking the ones we really like. So that's kind of nice. The signature algorithms uniquely determines the server cert and the signature scheme. And what I mean here is that the server simply said, the client simply says, I support these signature algorithms, and the server can supply any cert that conforms to those. The key shares and the supported groups together determine the key exchange. So the client in the supported group says, I would support these groups, and then the key shares he has, these are the shares that are actually giving you, and and then the server picks something out of that list or hello retry requests on them. It's been pointed out to me privately that you could actually merge these by having instead of having supported groups list, having offering key shares that were null key shares, basically they're empty. I personally think that's less elegant, but like those are equivalent data structures. So I'm not good at that. And the server's key share obviously tells you which group you picked, so you don't need to reference back to this. Right now, you have to reference back to the Cypher suite and look to see So right now, it's possible, for instance, to say for the client to offer FF2048 and 25519 and offer an ECDHE and DHE Cypher suite, and the server to respond with a DHE Cypher suite, but an elliptic curve share, and the client's supposed to check that. I don't know if the clients actually do, but the clients are supposed to. And so obviously this makes that impossible because basically whatever the share the server gives you is what he wanted. And so all you have to do is validate the server sent you a share, and that's a much easier check to make in the system. So is this all? So I guess maybe do people want to talk about this, or do you want to see what you have to do to make PSK work before we talk about this? Because if you hate this already, then you're going to hate the other part. So you can just skip past that discussion, right?
Hanno Böck, what's not answered for me is the hash function for the signature algorithm.
That's in signature. Oh, so that's in signature schemes.
So you have like a set of RSA PSS with SHA-500.
Correct.
And
That's all. That change was made about a month ago, courtesy David Benjamin.
This is DKG. I don't think that we need to solve this now, but I know that we have talked in the past about offering signatureless static Diffie-Hellman mix-ins. So would that mean that we would define a new signature algorithm that's no signature, just static Diffie-Hellman, or would that somehow get mixed into the key? Because those then end up collapsing, right?
Right. I think you would call that. Static Diffie-Hellman signatures. Yeah.
Okay, but now there is a coupling. If we do that, I'm just pointing out that there's a coupling between. So if I offer 3 signature schemes, and
yes.
So
I think
it becomes a little bit less orthogonal if we
I agree.
If we want to consider that.
Yeah, I agree.
Antoine Delnier here from MSR. Just to point out that, to expand on these comments, what you are losing here by doing that, I'm actually in favor of the change, but just pointed out that you actually lose some protocol modularity by doing that, in the sense that many previous TLS versions were using non-Diffie-Hellman or PSK-based key exchanges that you have no longer any way of specifying as an extension, I think.
So you mean like SRP, for instance, right?
Exactly, yes.
Yeah. So I guess my general sense about those things is that it was a kind of a mistake to try to wire them into TLS, and that they weren't very good fits, and that we haven't really made any attempt to accommodate SRP or JPEG or anything in TLS 1.3. I haven't even looked at how to fit them in, so I'm not sure they can fit into the current structure in any case. So I guess what I'm optimizing for at the moment is ease of implementation and ease of design for, I think, the main run of cases, and I think this is a case worth sacrificing. If someone feels differently, I'm certainly happy to hear about it.
Sean Turner wants to know if we're still adding the IETF recommended and no comment columns in the registry.
We would still no. Well, so for Cypher suites, we would no longer. For Cypher suites, we still have to, but we'd probably define a new. I think the way we would deal with that would be that we can have a separate draft which assigned all the existing Cypher suites IETF recommended no comment, and then this would only have to assign the new ones we generated, and we'd have to have, and we already have to have those. We already had those for groups and signature schemes anyway, so or needed them.
So Martin Thompson, in terms of the PAKEs and SRPs and the like, I think if someone wants to try to fit those into TLS 1.3, that's a separate exercise, and that may be unpleasant for those people, but I think that we're kind of making the right decision in terms of the trade-off here.
I mean, those always basically involved having some Cypher indicator that was like, I'm going to do a bunch of weird shit in the rest of this handshake anyway.
David, Benjamin Google. One quick thing to add to that is that we still have the extensions field. So if we want to like add special snowflake auth, we could add a special snowflake extension where you offer the parameters for your special snowflake auth, and then if the server decides to act it, then like that munches into the key schedule in some interesting way. Probably would need to think about how well that actually works, but I think we probably still have it in.
Russ Housley. So Eric, I think you said that the second bullet carries the hash algorithm used for the signature, but the first bullet carries the hash that's being used in the PRF.
Those are already distinct.
And so it's possible to put several choices in the front, several choices in the back, right? That then let you end up picking very different hash functions for the two.
So in fact, that's either a feature or a misfeature of TLS 1.3 as opposed to TLS 1.2. It's quite common. So 1.3 stacks absolutely support, for instance, SHA-3 to 4 signatures with AES 128 SHA-256 PRF. And in fact, that we ran that bug in interop testing where boring SSL tried to do that and an SS wouldn't take it. So that's an intentional feature of 1.3. I think that this gets back to Martin's point of the server is an option not doing that. The client is not an option of saying he doesn't want it, other than only offering one length.
So if the server picks a choice that the client can't live with, it can only hang up and has no way to negotiate one that will work.
Right. What the client has to do if the client wants that is the client has to only offer a consistent profile that is polarly orthogonal. So I mean, if you think about it, like you should be offering Suite B level 1 or Suite B level 2, but not Suite B level 1 and 2. Those aren't coherent.
Yes, I have another comment. Why not go all the way with this design change? And by that, I mean, why still negotiate the PRF in the cipher suite? Because if you look at historically, the hash function that appears in cipher suite name, it was actually used for the record level macking.
Yes.
And this has been kind of piggybacked to be PRF but in TLS 1.2. But if you actually want to say that cipher suite corresponds to the record algorithm, then why not negotiate the PRF like signatures? And
I mean, you certainly could. It's just one more thing we have to deal with. And it doesn't seem like it added a lot of value. I mean, I think that would be something which we could consider if we thought we wanted to go this general road.
Okay, any other comments on this? Not, maybe we should just get a sense of the room as to.
Yeah, I mean, I think, yeah. I mean, because if people think this is horrible, then I won't check out PSK.
Your Honor, Chef, I think this is an improvement, but if you're forcing some clients to send multiple proposals, one after the other, like the Suite A, Suite B thing, maybe you should allow them to say somehow, this is my proposal, but I have some other proposals in store, so that you don't have an actual fallback situation with everything that entails.
It seems that there is some risk that this introduces a fallback scenario.
So I mean, so it's already the case that it's already kind of the case that you can say incoherent things. So I mean, so in particular, it's already the case that you can say the most obvious incoherent thing you can say is, I would like a cipher suite that has a base PRF hash that is different from the hash that you're signing with, or I would like a cipher suite that has sort of a nominal security strength of X, but I only support keys with like an insanely different security strength. So give me an example. I can say I support AES 128.256, but I only support P521. Like absolutely, so I mean, it's already possible you can say things that are incoherent and nonsensible. I'm not sure this actually makes the problem that much worse. Largely the thing you used to be able to say that you can't say now, we want to do this, is you used to be able to say, for instance, I would like all is to say, I'd support, all finite field math and all elliptic curve math, but I won't support, I won't support use of finite field key exchange with elliptic curve signatures. And you wouldn't be able to say that. But It's already the case that because you're orthogonally negotiating the groups and the groups for the signatures and the key share, that you can say things that are really inconsistent about security levels. It's really the thing that's really different. The thing that's really changing here is the ability to sort of mix and match between NIST and non-NIST and finite field and elliptic curve.
This is DKG. I'm generally supportive of this change as well. I just want to think a little bit more clearly about how it relates to the version. So we have these new star cipher suites.
Yes.
Do we expect those to be meaningful in TLS 1.2?
No.
Okay. And do we expect the existing cipher suites to be meaningful in TLS 1.3?
No.
Okay.
We're just shoving it in the same field.
Right. I think that's useful for people who are thinking about fallback logic and that, just to be clear that these are sort of partitions of.
Yeah. And my implementation treats it that way.
So is there a column? Are we going to put a column in the cipher suites registry that says 1.3 yes no and 1.2 yes no?
I was thinking we just name them differently, but I could put a column in too.
It seems like
we already have this problem.
that these things are relevant for 1.2 and these things are
Right.
relevant for 1.2.
Yeah. So we already have a 1.3 yes no. We don't have a 1.2 yes no, but we change that column to say version instead of yes no.
So Martin Thompson, we already have that problem with the existing set of cipher suites. In NSS, there's this great big case statement that says, this cipher suite is good for this range of versions, and some of them only go so far as, I think we have some that are SSL 3 only, and some that are only 1.0 and 1.1, and some that it's 1.2 only, and this actually simplifies it a whole lot more. What it does mean, though, that when you commit to a version, you really commit to that version, and that's actually a good thing, I think.
That's actually true for every implementation I know. They'll negotiate version first, and then they try to make sense of things.
It's the only sensible thing to do.
Yeah. Agreed. Agreed. I'm sorry, I wasn't disagreeing with you.
Yeah. It's the most sensible thing to do, which is commit to the version, and if something fails from then on because you've only been offered cipher suites that are no good for that version, well, someone's screwed up then. That's all.
Okay, we haven't seen the PSK portion of this, and I know you're all eagerly awaiting that. So, but I want to make sure that there's people in general I haven't heard anybody come up and say this is just a non-starter. And if anybody feels that, okay. So should we move on to the?
So the PSK, unfortunately, we valiantly tried to make this simple, and we think we made it as simple as we can. We had some initial ideas that were we'll invent these signature schemes and key shares called PSK. So sorry. Here's the underlying problem. The underlying problem is that PSK is not used necessarily on its own. It can combine with the elliptic curve Diffie-Hellman or with Diffie-Hellman key exchange, and we don't currently allow it. We have a proposal from Martin Thompson to allow you to combine it with a signature from the server. And so, the motivation for this, in fact, was trying to figure out how to express that semantic, namely, I would like to do PSK, but I'd like the server to demonstrate to me he still controls his private key. And I can go into motivation for that if you want, but and just saying that's something you'd like to be able to express, at least in principle, even if you decided you didn't let people say it. So the difficulty is finding a way to say that. So we had a bunch of ideas that were we'll have these fake, key shares that were I would like to take only PSK, and so if you offered the PSK key share, then that meant just do PSK, and if you offered only Diffie-Hellman key shares, that meant do DHE PSK, and that didn't really work out very well. So what we finally came up with is I actually set 2 versions of the list, but I'll show you the one I like better, which is basically taking all this complexity such as it is and shoving into PSK itself, PSK indicators themselves, so that makes the public key stuff easier, and puts the problem where it was created. So the idea is basically to have two sub indications in the PSK identifiers themselves, or the PSK proposals, that say you may use this PSK. These are from the client to the server. Dear server, you may use this PSK alone, or you may use this PSK with Diffie-Hellman, or you could do either at your choice. And as usual in TLS, these are ordered lists. So now. It's probably not really sensible to say. It's probably not really sensible to say both of them, but you might want to for some reason, or you might add a third thing, right? So basically, what happens is the client sends the server a list of keys, and it says, as usual, and it says, if you use this key, you must also sign, or you must not also sign, or you may sign or not at your discretion. And similarly, you may use a DHE or not. And then the server responds with the one he's picked and what he's actually going to do. Now, I think the first half of this is obvious. Namely, the client says, like, well, here's what you can do, and the server has to pick out of it. The second half is less obvious. I'll get to that in a second. We also, of course, take these exact same bits and you shove them in the new session ticket message so that the server can tell the client what he could actually in principle do. So you don't have a situation where the server like only supports ECDHE resumption and the client says, I only want PSK resumption. So you want to give so the client has to be given some idea what he can do. Right. So why does the server have to tell you anything? So the server actually does not have to tell you whether he's doing Diffie-Hellman or not, because you can infer that from the key show the server sends you. What the server has to tell you is whether he's going to sign or not. And the reason you wanted to tell you that is that way when you're processing the messages from the server, you know whether you're looking for a certificate verify rather than having to just go, is there one there? What the heck am I doing? And of course, these happen during phase of the handshake. Namely, you need to know the Diffie-Hellman phase, even to get through the server hello. But the rest of it, you want to process in sequence. I'm less happy about this last indication here. Namely, it's not clear why you're sending the key exchange, because as I say, it's kind of redundant. It's an opportunity to get it wrong. This is not like my favorite way of indicating. Well, maybe my favorite way, but it's not a pretty elegant way of indicating whether you're going to sign or not. The other major alternative I've seen for testing how you're going to sign or not will be to strike both those bits out of the identity, both those lists, and to have the server send you a signature algorithms indicator, an extension in his server hello. And if he sent that meant he was going to sign. If he didn't say it meant he wasn't going to sign. Actually, that could go into crypto extensions as well. So there's some debate on which of these alternatives is more aesthetic or not. I guess I'll let that debate commence, but let me first say that we're not using that signature algorithms thing for anything right now, so that would be okay. But we discussed using it for something, so maybe it would not be okay. Anyway, there's a number of ways to indicate that, but and I don't want to get too bogged down in this particular encoding, because there's at least one other encoding we discussed that involves flagged words instead of lists. But I think that this is like generally how I pose this negotiation.
Yeah. So Martin Thompson, ultimately this really is just flags, just a question of representation.
Yes.
The having the auth mode in there and having a signal avoids a number of the problems that we might have analogous to some of the SMAC TLS stuff that Karthik was doing a few years ago on implementations that failed to actually apply keys in certain circumstances. And if you looked at the key schedule that you had on the previous slide, there is actually an opportunity to have no entropy entered, and that gives implementations a hook to look at and say, I expect to see entropy coming in at these points, and you can actually sanity check it. It's not like you can avoid having checks in there, which is a little unfortunate. We've tried to avoid forcing checks on people, but I think this is a really neat way of making sure that you actually have entropy entering at the right points in time. Of course, it's PSK, so you're always going to have PSK, but it means that you avoid all of the sort of extra checking, and you know what you're checking for ahead of time. Okay, I don't like the KE mode in the server indication of the thing. I think it's just
right. I think the invariant is that you must tell the server must tell the client what he's going to do, so that the client can't infer it, right? And I think he can't infer that he's going to sign. The KE he can maybe infer, but maybe nice to double check it.
Yeah. And I have designs on signature algorithms, so
don't use it, right? Deb.
Deb Cooley, NSA. So I don't quite understand how this works, but is there, at all?
Okay.
Is there a way to make your Chinese menu just included?
We couldn't figure it out. Doesn't mean that it can't be done, but we couldn't figure it out.
Yeah, so is it just another orthogonal piece?
Yes, but the problem is it's not totally orthogonal. So I mean, I spent much of yesterday actually implementing this because I wanted to actually be able to talk coherently about it. So what you have to do to make this work is you basically say, provisionally, I'm going to set this PSK, and then validate essentially that everything is consistent as you try to pick the rest of the parameters. And then if any point is not consistent, you just abandon the PSK and fall back to, and you basically are running the regular negotiation quasi-parallel. So it's easier than it sounds.
Okay.
Basically, let's talk about the
Let me ask you one more follow-on
yeah.
question. And that is, can I now use PSK to add just to KE without using it as an auth?
So let me try to answer that crisply. You could use, this would allow you to express, I would like a key that is based purely on a PSK, but I would like you to sign to prove who you are.
Yes.
Yes, this would allow you to say that.
So, or a PSK with a ECDHE combination, and then I want you to sign to prove.
Yes, this would allow you to say that as well.
Awesome.
Hi, Nick Sullivan. So one of the things that hasn't been mentioned that we lose in this proposal is the ability to signal client preferences for more than just the AAD and PRF. Are there any thoughts on how to bring back the client preference in all these other separate pieces of the negotiation?
So this actually does, because each of these other things is also ordered, you actually do signal the client preferences. So if you go back to the previous slide, I guess.
Is this made explicit?
Yeah, so everywhere in the spec that there's a list of things, it says client's preferences first.
Okay, including this,
which
is another advantage of this.
There's no spec for this, but yes, it would say that. That's in fact, that's the advantage of this encoding rather than the bitmask encoding. So one thing I do want to mention is that that parenthetical new is exactly referring to the case that Deb was just indicating. So we don't yet have any any cryptographic analysis for this mode, but the motivation for the resumption context was precisely Karthik's attempt to make sure that mode was safe. So we have to have analysis for it, but one of the motivations would be exactly to allow that mode.
Yeah, Rick Saul's kind of channeling for the whole chat room. So I guess the PSK stuff, be handled purely at the API level, right? Because you have to persist stuff from previous attempts. You have to persist stuff for PSK from previous attempts.
Not necessarily.
No, so our implementation, and I believe the Chrome implementation, when it does it probably, treats PSK as if it were session resumption and hides it under the covers. In fact, so another advantage of this design is that when we had is that you would is it in the previous version you would like negotiate TLS PSK ECDHE with AES 128 GCM, but you based on your previous negotiation with ECDHE with ECDSA, and then in order to keep TLS API consistency, we have to lie about the cipher suite upward and be like, well, I'm not really negotiating PSK, I'm really negotiating ECDHE, right? And so this is it creates a different class of lies, but it's a simpler class of lies.
Okay, it's a more truthful lie. Yeah. All right.
Well, I mean, I guess, yeah.
All right. The second thing is, how are you guys configuring it in terms of everyone's favorite OpenSSL ciphers?
Yeah. So I think actually OpenSSL ciphers actually probably pretty straightforward because those are quasi-orthogonal in any case. I mean, they're a mess, but
I mean, yeah, I guess it's gonna have to have a sub-separator character inside the colon separator.
I'm thinking maybe David Ben could talk about this.
Yeah, we actually have stuff in NSS now that allows you to do that sort of thing with the language and all that sort of other stuff. And we have APIs that will turn on and off named groups independently. I don't think we can order those. Order and turn on and off signature algorithms, order and turn on and off cipher suites or the AAD PRF. I mean, it's just all part of the existing stuff that we have.
So what you would do here, by the way, I mean, to configure these modes, either the stack would just take a position on it and not let you decide, or the stack would have some separate fraud that would say, do you insist on Diffie-Hellman when you do resumption or not, basically.
Yes.
Yeah, David Benjamin. Basically that. I think so for the OpenSSL type cipher suites, most of the information in a TLS 1.2 cipher suite that's not the AAD and PRF is already basically irrelevant in TLS 1.3. All of our ciphers look like ECDHE, and the part where you have RSA or ECDSA in the cipher was always kind of weird. So I think the implementation can decide exactly what they want to do, but I could imagine any sort of thing where you like maybe post-process lists to extract the like AADs you actually ended up picking, or maybe you say that like, okay, if you put a cipher suite by name, then we won't match the TLS 131, and so you really need to say like the selectors, but that might like, I think probably you'd want to do a post-process and extract the AADs and put them in, and that way you can transparently turn 1.3 on. But there's a number of options you could toy with, depending on what backwards compatibility constraints your implementation has and whatnot, but it's solvable.
I mean, one advantage of we have with 1.3 is that all the cipher suites that are accessible with 1.3 are basically strong, and so you're and so if you're like, you don't have to configure it to have it not do crazy things. Today, yes.
This is DKG. So I think this is a good process, but thinking about implementation side and deployment side and being an administrator or operator of a client, I'm wondering whether the implementers who've done this and who've thought about preference ordering and things could agree to, and perhaps document, perhaps in a draft, a textual string representation of how client preferences can be represented and how server preferences can be represented. Because the OpenSSL ciphers for 1.2 and prior is kind of a mess. And there are other TLS implementations that don't speak that particular dialect. But if we had a clear statement of, here's a textual representation of these preferences for both client and server, then everyone who's implementing it could just adopt that, and we'd have a much easier time going forward.
I think we'd be at least amenable to discussing it. I mean, you would need multiple axes as opposed to what you have now, right?
Sure, but I mean, presumably there is still some textual representation.
Yeah, that's okay. I mean, JSON or something, right? But maybe CBOR. Base 64 encoded CBOR, DKG.
Awesome. So this is Debbie Cooley from NSA. So the reason I was standing in the back was I was going to ask you at the end of all of this how you were going to document security considerations for this.
Yes.
Because you're going to need to help everybody else that's implementing this to do it. And it would be wonderful if you were recommending that things were matchy-matchy, you know what I mean? Right?
I know you guys love matchy-matchy.
No, yeah, we do. We're obsessed. But, you know, because that's what you want to aim for, right? Is to have things be sort of same-ish.
I'm not sure David does, but.
Yeah, I guess I'm actually about to say the opposite thing. To DKG's point about having the common language, we've like actually, so unless you want to do matchy-matchy things, in which case I'd have to think about it. But if you don't want to do matchy-matchy things, we like don't need a language anymore, because the only like you just have like several lists and like, okay, the string form is we decide a string name for each AAD, which is already in the spec. The thing that makes like OpenSSL things more complicated is that we have these like semi-orthogonal but not quite orthogonal things, and people probably want to say like, people for some reason want to say interesting things like give me all RC4 ciphers. Well, I hope you don't actually want to say give me all RC4 ciphers, but because of that, you end up having these like weird selector combinator type languages. But if it's just a list of like things with concrete interfaces, then there's no need to say anything.
Right. In fact, the way you say it right now, the way you say give me all RC4 ciphers, or you couldn't say that, but the way you say give me all RC4 ciphers would be, you know, to define AED RC4 and say like, and then add that to the list, and you should be done, right? I think you've nailed exactly the problem. The reason the interfaces are so clunky is that we have something which is quasi-orthogonal, and they're trying to describe it in a quasi-orthogonal way, but neither the description language nor the target are actually orthogonal, but they're not orthogonal in different ways.
Or another way to say is that you would never actually want to say in your language, give me all GCM cipher suites, or give me all cipher suites that like have counter mode in them somewhere. You'd like probably just list out the AADs. And
well, it's not even a coherent statement now, right? Okay.
So this is DKG, just to clarify, I don't think it's fair to say you don't even need a language. What I'm saying is, even if it's really simple, write down a concrete representation for it in string form that can be passed to the different pieces. If we have that and we have a standard way to do that, then it will be much easier to like work with different deployment stacks. So even if it's just stupid simple, a draft that says you take these things, you separate them with commas, you stick colons between these things, this is how you know what they are. Like, yeah, let's get it clear so that we don't have 5 different variants and I have to go.
Would you be willing to help with that?
Yeah, sure, fine.
I'd be willing to work on it if you'd be willing to work on it.
Yeah, Rich Sauls, just to emphasize DKG's things and being more sarcastic about it. I mean, representing OpenSSL, we've got a lot more clients than the one each that NSS and Boring have.
Yeah.
You know?
I think I'd be happy to work on something like that. If the people, I guess, if the people who had stacks are willing to work on it, like I don't want to find something nobody uses.
Yeah, I also think that sounds like a good idea. I would ask though that you at least consider the possibility that some Cypher suites go bad or some algorithms go bad in doing that. So you might want a not possibility.
Because your point is there's a default. Your point is that's how you express the default. The default is on and you want to turn it off.
Yeah, I mean, if you look at the kind of configurations people want, is over time in like 5 or 10 years,
Sure.
you might say, I like everything except.
Well, I mean, this is something. I mean, which we have to talk about actually at the draft. But the interaction, like, is this designed to provide a complete profile of everything you want, or is it is designed to be somehow merged with some existing set of preferences which are in the implementation? Is exactly the API choices that gets difficult here. So like NSS, for instance, has got like its own set of API choices, right? And its own set of default implementations, and you know, and then you can turn them on or off. But if you don't do anything, you get something, right? And so, okay, next slide. So I guess when we started doing this, but you know, obviously this is a big change at the last minute, but and it makes the it makes the programming API about this easy, makes the downward API easier and makes the upward API slightly more complicated, in the sense that the upward API people are used to like being able to say, give me the Cypher suite. So people have adopted an idiom, which is not the right idiom, but nevertheless an idiom they adopted, of just give me the Cypher suite that tells me everything I want to know about what's going on, right? And that's not really true because it doesn't tell you, for instance, what elliptic curve group was negotiated, but people have been doing it anyway. And so people will have to adapt, or the implementation will have to sort of lie and fake up some Cypher suite to tell you what it did. So that will make the upward interface a little more hairy, but it'll make the downward interface actually quite a bit easier.
There's nothing stopping an implementation from formulating that language on its own. Microsoft have been reporting the elliptic curve group in the Cypher suite for a very long time.
Yeah.
And you could just synthesize a whole
Yes,
bunch of
absolutely.
strings that
Yes.
had all the various combinations. I mean, you wouldn't be able to turn off just one of them.
Yeah.
But
No,
they still do all the reporting.
absolutely. I just fresh in my mind. I think the big con is it doesn't let you adjust these non-orthogonal points of the space, but I've come to the conclusion that was a mistake to attempt to facilitate. I think the pros are, this is like a lot easier to write your code. The evidence that we have is David's opinion, my opinion, Martin's opinion, and actually my prototype implementation, which no doubt is full of horrible bugs, but like at least does sort of do something. So it's much cleaner. It removes the sort of odd, this sort of the ECDHA PSK Cypher suites, which are always kind of gross, and it's more expressive in a number of ways. So as I say, I resisted this for a long time, but on balance, I think this is the right decision to make. So my proposal here is that I guess I'd like to get people sense that if they want this, and if they want this, then I'll produce a PR probably this week, and if not early next week, and provisionally adopt this pending actually producing text. So that's how I propose you proceed, I guess.
Okay, any more discussion on that? If not, we'll take a hum. Okay, so the questions will be, do you support moving to a menu approach for the Cypher suites versus keeping it in this monolithic Cypher suite representation? So first question will be, do you support this change? And the second question will be, do you oppose this change? So for those in the room, how many people, or how many of you support making this change to a menu-based Cypher suite system? Okay, how many of you are opposed to making this change? Okay.
So I'll strike when the iron is hot. You'll see a PR real soon. Okay, next slide. Oh yeah, right. So it turns out that if if you send, a client hello with version 3, 4 in the client hello field, in the client version field, some non-trivial fraction of servers choke. We're not sure what that number is, but the percent or so seems to be the sort of number people think about. And so until recently, I would have said all existing browsers. So again, I'm thinking of browser guy. It's like amazing how fast you go to the browser company, you think of a browser guy. Like it used to be like stupid browsers, but so anyway, non-browser systems basically don't worry about this because by and large, you just tell people to upgrade one side or the other and you don't worry about it. But if you're a browser, you have to worry about this. And the browsers basically until recently had this logic called fallback, and they basically be like, if anything goes wrong with the connection and you offered the maximum thing you should do, try offering something cruddier and see if the other guy takes it. And maybe if he takes it, you're happy. And that's and I should mention that's actually been a really useful feature because it's how we got rid of RC4 basically. But it's also kind of a pain to implement. But as I say, it's also been very useful because it's basically the way we got rid of RC4, courtesy of Andre, was you would not offer RC4 and then the servers would choke and you'd fall back to offering RC4. And that meant that there were lots of people who, because there were lots of people who would pick RC4 if you gave it to them, but if you didn't give it to them, it actually would negotiate something else. So, so as I say, I used to say everybody does this. Then some guy at Google pulled this out of his stack, and so David came and yelled at me for a while about how much this sucked and how really we should not recapitulate this mistake, this alleged mistake in TLS 1.3. The mistake being obviously having a version negotiation mechanism, which apparently is too complicated for people to do, comparing two numbers, and so people screwed up, and so we just ain't different. So again, resisted this for a long time, and I'm not taking a position on this, but I figured we should discuss it. David proposed something. This is my stylized version of what David proposed, and we can discuss it now. So the proposal is basically to keep the client hello version as it is, offer 3, which is TLS 1.2, and then have a new extension, which basically is a list of the versions to support. Now, you might have thought that you could just recapitulate the version number in there, as the maximum version, rather than having a list of extensions, but a list of versions. But there's a reason for giving a list of versions, but I'll get to in a second. So basically, you say, here's a list of all the versions I support, and we could fight about how they can be encoded, whether it should be whether they start at 0 or they should start basically where you start now, and whether you should list the ones that are before TLS 1.3 or not. But anyway. And then the server just picks whatever he likes out of this list, and this list, I guess, is quasi-ordered in some way, but who knows? I guess in traditional TLS style, it's probably ordered in your preference order. And then David's proposal is that the server would contain the server hello, however, would contain his version field, a negotiated version, which in this case is higher than the version that was in the client hello. And then we negotiate all future versions this way. And in order to keep this functionality live, David would periodically send you insane versions that you are hopefully not going to support, and trust that, and trust you didn't choke. And if you choke, then David would come to your house and kill you.
David Benjamin. So yeah, I want to do that to basically every single list we have. I want to burn a range of Cypress suites, extensions, and everything. I'll just make Chrome pick random fake ones in every client hello. I'm kind of tired of fighting this intolerance game. We almost had to roll back X25.19 because it turns out some ancient Erlang TLS implementation barfed, and I want to be done with this. So yeah, so I actually want to burn something dumb like the two numbers XOR to 42 that you can't possibly determine, but I think Ayana will probably kill me. So I think if it's a range, I want to get so if an implementation is actively trying to be intolerant, then okay, you lose and I'm going to just break your server. But what I want to get to the point is that if you make a mistake in your implementation, you will not interoperate with hopefully more than just Chrome does this, and you will not interoperate with a large number of clients, and then you will realize that maybe there's something weird here. I should ignore unknown versions. I think the Erlang one, they did a switch case and forgot a default, and I guess the way you do things in Erlang is you just crash the process because I don't actually know Erlang. But anyway, so hopefully they would notice that and be oh, I should add a default case before they actually ship the software. Because the problem is right now, the existing clients will by definition interoperate with whoever with like servers people put out. The problem is that like N years down the line, when we want to exercise a like little exercise protocol joint, that then realize, oh, they actually could only handle the ones that existed today. But if we have fake ones, then I'm hoping this will work because everything else seems not to have worked.
So anyway, I'm presenting this for your discussion. It is revolting. It may be right. I'm not sure about that, but I think we can all agree it's revolting. We need to decide this. One thing I wanted to briefly mention is that the mechanism we've been using for allegedly preventing interrupt failures with draft versions, as David pointed out to me, does not work well. So right now what we do is you advertise version 1.3 and you put in an extension that says I'm draft version 47 or whatever, and the other people are supposed to not do 1.3 with you. But as David pointed out to me, what that means is that when you actually field the final version, then the servers have to, like, for a very long time, look for old draft versions and reject them until basically all those people have expired from the internet. And so that means you can't ship any draft versions in ESRs or anything like that because you need them to time out. So that's unfortunate. So this would solve that problem as well. But there are downsides to this as well, I think, which are obvious too.
Yeah. So Martin Thompson, I really don't like this. I'd rather we stop after the first bullet point. And the reason I say that is that you're worried about all of our extension points seizing up. So let's just add another one. I would rather us just say if there is a particular extension present, maybe key share is the one. Is that the only new one that we can guarantee will be present? That we can't even guarantee it's going to be present, can we? Right. So if there were some combination of extensions that were already guaranteed to be present, we could just walk
Key
away.
share or PSK must be present at present.
Well, is PSK new? It's old, isn't it?
No.
Oh, it's new?
It's new.
It's new. So
Yeah.
we're done. Either one of those two are present, then you're doing TLS 1.3. And if someone wants to do TLS 1.4 or TLS version 70, then they put a new extension in and see. That remains the signal. Then we don't have any more extension points.
Right. So I guess one thing to say about this is that the alternate version of this design is to simply have I support TLS 1.3 extension.
Yes.
As opposed to the sublist, right? I presented this version because it's slightly more compact. But if for some reason you think that's the right design, like obviously that's essentially the same aesthetic properties.
Yeah, so I would prefer to have I support version 1.3 extension simply because it's fewer joints to seize up.
Yeah, David Benjamin, I'm happy with either. I think we can defend extensions in the version list equally, but so if we always have a new mandatory extension every version, then that's more compact. If we don't, then this is more compact. I really don't care.
One thing to say about this is a new extension would not let you indicate preference order. That's what we have now.
Hannoberg, I like the general thinking behind this proposal, like that you say we kind of test by sending stupid versions, but this changes a whole lot of things, I think, from the logic. Like with this, you could say things like I support SSL version 3 and TLS 1.2, but not TLS 1.1 and 1.0. I'm not sure if that has other implications, like that you now have a list of versions instead of a range, and yeah.
Yeah, that's quite right.
Also, it adds like another indirection, like people in the future will wonder, right, we have this version in the hello and then this other version in the, which then only has historic reasons.
Yeah. So Bode also pointed out that this lets people effectively do sort of unofficial forks, like that you do, like, I support TLS version 922. And nobody, I mean, so that is useful for draft revisions, but it's unuseful because you might co-put stop it.
So this is Deb Cooley again. So this is ugly. And it makes it more complicated. And if you just left it the way that it was, you can still do the unofficial fork thing by saying 3 comma, whatever the heck you want. I would much prefer to send David to Keldon to begin with.
Well, he does have Valdez and Harper now, so maybe there's enough manpower to.
Or have David come to me, because there's probably servers in an area that I have influence over, and we can make them freaking update. right? Because it's old stuff you're
Yeah.
talking about. Make them fix it, damn it.
And that has been my position for a very long time. And I'm still, I have a certain amount of adherence to that
However, I'm
position.
not a browser vendor, so. yeah.
Well, we already have this code. We already have this fallback code. So if we're not, it's David who took it out, who foolishly took it out. Like, you know.
Yeah, Chrome does not fall back anymore. I've deleted the code. Yeah. What was I going to say? I don't remember what I was going to say anymore.
So, Mike Bishop, just commenting, didn't we already have this conversation with TLS 1.2? Because we certainly played this game then.
I think when 1.2 was defined, I don't think it was as widely, 1.2 didn't have as much browser manufacturer involvement when it was designed. And so I think basically it wasn't as widely known. I'm not sure I knew that people did this. And so I don't think it didn't come up.
Okay.
And then basically, then people started realizing they had to fall back, but it wasn't a, I mean, also the fact that,
1.1 and 1.2
I think also basically 1.2 was defined before people knew about this, basically.
Hi, Antoine again. So I have some comments again. So one thing that was removed in 1.3 is before in TLS, there was a branch version negotiation mechanism through the record version in the client hello, basically. What you would do is you would put your minimal client version in the outer records and your maximum one in the client hello itself. And this is no longer possible because new TLS 1.3 requires to put 1.0 in the records.
Right.
So it's
Well, it never worked, right? I mean, 1.2, if you read the 1.2 spec, there's a section on like, this is what you can, there's no value you can safely put here, but this is the value we suggest you put here, basically.
Yeah, but I mean, it sounds like a case where this sounds like two outrageous proposals. One is getting rid of the historical version negotiation, because basically if we don't put 3.3 in client hello, then there won't be any more version negotiation through the protocol version, which is quite upsetting. And using another even more outrageous proposal to make it accept this one, because we can basically do it based on any 1.3 cipher suite or any signal. But still, what is the long-term plan for dealing with protocol version negotiation as historically defined in the protocol itself? Seems like a much better approach to have the chromes and I don't know, for the 55 protocol version in the client hello and force these guys to update.
I think it's Eric.
Eric Nygren, I like the idea of having the explicit list of supported versions. I guess one question though is whether, do we have a sense how much of the version negotiation problems we're having are from servers versus unfortunate middle boxes that are looking at the clear text and trying to enforce some policies, because
that might make this worse.
Because this is not going to help that. That may actually make those worse rather than fix up some of those problems, even though it might help with the servers.
And that is a measurement we could take. We're still pending a measurement on the record layer, so.
David Benjamin. So the intolerant middle boxes are all dead and gone, and I hope they stay that way, because like we deployed fallback at CSV, and I assume if we end up not doing this and having a fallback for 1.3, we'll use the the downgrade protection in the server random. So if the fallback works, it will only be if the endpoint is intolerant and not the middle box. So like
Well, there could be in the middle boxes that explicitly check for version number matching and choke on that, and this would break them and otherwise wouldn't break anybody else.
That's true.
I mean, great. I suspect those middle boxes probably check all the other parameters of the server hello and also choke, but I'm just saying it's conceivably possible.
Ben Schwartz. I think there might be a way to get both of these benefits. So if we just increment client hello, like normal versioning people, but then if the IETF agrees to take like 6 months off at least between version numbers, then for those 6 months, browsers can lie upwards about their version number in client hello and break any servers that are intolerant for that period, and basically for as long as needed until they're fixed. And once they're fixed, then the IETF can start developing version N+1. And the browsers need a time limit at least so that they stop reporting N+1 after a fixed time period.
That's a horrible idea, but I'm not sure more horrible than this.
You first.
Christian Wittema, Microsoft. I'm worried about particular use case of all the new IoT systems and others which want to have a simple software, and they want probably to negotiate that they only support 1.3 and do not want to fall back to 1.2. And in that case, the extension approach that Martin was proposing just doesn't work because it doesn't convey that semantic.
I've got to answer that one. So if you only want to do 1.3 and don't want to do 1.2, and the server is inclined to pick 1.2, guess what? You don't have anything in common.
That's correct.
So it fails.
If you key off the cipher suites, right? Because we now have disjoint 1.3 and 1.2 cipher suites. So if you only do 1.3, then you offer the extensions, and your list of cipher suites must not include any 1.2 cipher suites.
So basically, if what I want to say is I want to do that, you can effectively rely on your safety net that it's going to fail in some crashy way, and you just crash the connection. Or you can exactly say that, well, I just want to do that.
It fails when you get the first response from the server. What's the problem?
Should we change that?
David Benjamin, I just wanted to make a comment to so if instead of this having the browser's fake higher version, I actually considered doing that, but I think it's a little bit too late now. So the problem is we need, so say we all agreed that like TLS 1.3 is not going to exist until 2018.
1.14 you mean?
Oh, 1.4, okay, so you're saying like.
He's saying we accept the fallback now.
Okay.
And then we loop it with joint next
Okay, sure.
in a year.
Like the nuisance is that you need to stop new implementation. You need to stop the implementations from getting to the ecosystem first. Like once they're in the ecosystem, like I can't break them. I can only I can add a fallback and monitor, and then like I can tell everyone, okay, guys, it's safe to turn on TLS 1.4 now. But I would much rather prevent it from existing in the first place.
Yeah, I think as I understood Ben's plan, it would be that we would do what you would basically you'd re-add the fallback, you get the 1.3. You get to the point where you could remove the 1.3 fallback, then you remove it, you start advertising 1.4 and basically pitching at people, right?
Sure. I think probably that in that case, I would just pretend to be 1.4 in the very first version of 1.3 we ever put out, and just like only ratchet that back down when we're ready.
Yeah, so that works.
It's a little bit odd, but I guess it might work.
Yeah. So I guess what I would suggest is the choice here is between keep the existing version mechanism versus adding something that is like there's a different one that deprecates the old version mechanism, and either that's like one of n different things people proposed, namely this proposal or Martin's proposal, or some other to be defined bike shedding of the negotiations attacks. I think that's the big question: is should we keep the existing mechanism versus move the new mechanism that is that basically using the existing safe, nominally safe thing.
Okay, so that means we think implementers are smarter now than they were.
That is the objection. That is the objection to this suggestion, right?
So specifically, this is not assuming implementers are smarter now, because I'm just going to make Chrome always send fake versions. So the implementers will not be able to get this, but they will not be able to shift their code, get this wrong, and interop with Chrome. And hopefully other browsers will be in on this game too.
As distasteful as I find this, I will say it has the benefit that when we decide to throw it away in the future, we don't have these vestigial bits hanging around. So we have the vestigial version octets if we add this thing.
Only the client hello and the server hello. We're
send this one.
Andrei Popov, Microsoft. So there are advantages and disadvantages to this. I think this is a different version negotiation mechanism for 1.3, which has even UI configuration, UI implications, for example, right? So in the past you had to have a range.
Yeah.
Now you can have this contiguous kind of selections, checkbox style, thing. and which one to use depends on the rest. So that can be pretty confusing to the user if you are to express this in the UI. On the other hand, the advantage is that, you know, if you have a non-standard version of TLS, as some countries do, you could express in this format. I think you could negotiate it more easily. So pluses and minuses.
Before you were insane to said it.
Philhan Baker, this problem seems to come up again and again. And it's rather sad that it comes up again and again because it seems to be rather core to the idea of creating standards. And so I would like, I think one of the problems here is that people don't quite understand what they want from versioning and when they want to break things and when they don't want to break things. And I think that maybe one of the things we should do here is to kick the IAB and say, you should have a plan for this, and you should have an architecture that working groups can apply, and maybe we don't keep doing it.
Tommy Pauly, Apple. So as a browser / operating system implementation, I think I'd prefer to keep the existing versioning and live with breaking people. And I mean, another approach is if everyone does equally just say break people who don't support the right versioning, then they will get fixed better. If we are going to do something funny, the list feels weird because if someone doesn't know how to support TLS 1.3, they won't know how to support the list. And why would we have a list that can include potentially way older versions? Because no one should be using those anymore. So if you're going to have something, just have I'm TLS 1.3, but I'd prefer not to. I'd rather just fall back.
Martin Thompson, to answer Phil's question, there is an IAB document that talks about specifically this problem. I believe it postdates the design in TLS. That is part of the problem we have here. And we're really good at ignoring advice. And I say that collectively as protocol designers and as implementers. We're really bad at this stuff. We have plenty of evidence to suggest that that's the case, don't we?
Ben Schwartz, Jigsaw. I just want to point out, I think the reason we get really concerned in the browser space about this stuff is because there's a game theoretic problem where no browser vendor wants to be the one that makes the increment and takes the usability hit and drives users to the other browsers. But I actually don't think that applies here. I think that basically we have so many representatives from so many browser vendors so excited about deploying TLS 1.3 that there's basically sheer force of goodwill can overcome the deadlock.
Okay, so let's get a hum to get a sense of where we're at. So the question will be, do you favor changing the current version negotiation mechanism? Hanno?
I think we have to consider three options. One is keep the existing mechanism with version fallbacks, or just don't do version fallbacks and break, or have something like this.
I mean, fallback isn't standardized. We just do it or don't do it. We're not gonna decide whether or not do it based on the IETF's decision.
But I think we have all the people in the room that have to make these decisions at the browsers. If they can agree to break, then we can do it.
David Benjamin.
I mean, there's no way to close that fallback today. I mean, the way this will work is, I mean, David could speak for Chrome, but the way this is going to work if we don't change this mechanism is we'll roll out 1.3, we'll have the fallback code for a while, we'll wait until it gets to an acceptable level, and then we'll put and then maybe we could do a coordinated fallback removal.
Yeah, if things stay as is, Chrome will deploy a fallback. I'm sure Firefox will deploy a fallback, and I'm sure the other major browsers will deploy a fallback too. 2% is far too big of a number, and there are sites like NewYorkTimes.com and Apple.com and who knows what else that people go to regularly.
Yeah. And to be clear, it's not a game theoretic concern; it's a user experience concern.
Yeah.
We're not going to deploy this because it'll break and some absolute fraction of sites, not because the other guy doesn't do it.
Yeah, I mean, even if we could all agree to do it, we still wouldn't do it.
Okay, so we go back to the basic question is, do you support changing the version negotiation mechanism, or do you think that that's a really bad idea? So question first is, how many of you support changing the version negotiation mechanism? Okay, how many of you think it's a bad idea to change the version negotiation mechanism? Okay, so it sounded like there was more support for
I didn't hum.
keeping it the same.
Yeah, I thought it was pretty strong. I didn't hum, so did you hear differently? Okay. I abstained. Okay, next slide.
One last comment on this. Users actually find the current version negotiation mechanism very confusing because they punch a hole in the version list. Sometimes they disable one particular protocol and expect that only that one will be disabled. But what they find, at least, for example, with OpenSSL, is that you disable all protocols above the hole. And so if you disable 1.1, you also disable 1.2 and 1.3 and, you know, sort of 3.1, 3.2, 3.3, whatever. You only get that below the hole and weaker. And they're totally shocked that's what happens.
Well, that seems like a defect in OpenSSL.
But you know, getting the semantics for that right and only punching the hole where the client can't communicate to the server.
Well, I mean, there's no way for the client to communicate that. I mean,
right.
I mean, like, I guess what I'm saying is OpenSSL should interpret the hole downward, not a hole upward. I understand the protocol will let you say that, but that's what it should do.
Right, but that breaks compatibility in the other direction. So that's why I was humming for the change, but I don't know if that was communicated here.
Okay. Right. Okay. Next slide. Oh, we're there. Okay, good. So the current draft implies that you should be able to do client authentication even if you're doing a pre-shared key presumption. And so why would you ever want this? Okay, I mean, the draft is kind of unclear on the point because like it has an example that shows you can't, but it has text that says you can. But like my intention was you're supposed to be able to do this. And what happens is it's just like what you expect. The server sends a certificate request in its first flight, and like the client responds with it, right? So like the semantics of this are kind of confusing and odd. What does it mean? There are two things it can mean. One is, I guess, three things. One is the client has not authenticated. Now suddenly the server, for some odd reason, would like client authentication. The second is the client has authenticated, and the server would like the client to prove that he continues to have the private key for the certificate. And the third is that the third is that the client, for some reason, the server wants a different certificate from the one the client has previously advertised, which I guess cases 0 and 3 are kind of 1 and 2, 1 and 3 kind of collapse. And so the semantics are kind of confusing, and it's kind of a pain to implement. And 0 round trip is even worse because like you've already accepted this data provisionally in some cases, and then you have like have this extra bit in the state machine that's like when the client finally gets around to sending me data, am I expecting a certificate or am I expecting something else? Several people, Sabode and others, came to me and suggested that that what we should just do is say, like, if you're doing PSK, the server must not send certificate request in the in his server hello. Sorry, his first flight. If he wants to at some point later prompt you for, if he decides what he wants is the client to authenticate, he must either reject presumption or he must do post-handshake client authentication. So that's a proposal that Subodh and Nick suggested. David Benjamin suggested an alternate proposal, which I think he actually likes less, but just didn't think he could get this good one, which is that the client, the PSK client auth only is allowed when it's like morally the same identity as the original identity, and so the client can just always basically send your certificate and not send your empty certificate and not actually certificate verify. But I think you actually like that less well, David, than main proposal. So I've thought fairly hard about like whether like what the arguments are for allowing this. And they're, as far as I can tell, entirely protocol symmetry arguments about like why are we making PSK and you know why is it just like all one thing? But I don't think those arguments are as strong as like making implementation simple and for something we don't really have much use for. But please discuss.
Hannes, I think it's a little bit confusing in a way because there are actually two different types of client authentication. So if you only have a PSK, a certificate request from the server doesn't make a lot of sense.
However, if you had PSK in the context of session resumption, initially started off with asymmetric cryptography, then the certificate request makes sense because you're not talking about the specific session, but you're actually talking about the earlier handshake that started off with the. So when you say at the last line, proposed resolution, ban client hours, to which one are you actually?
What I'm saying is, if you set the PSK, you may not off. If you set the PS, if you set your server and you send a PSK, you may not send certificate request. And any conditions at all.
Okay.
That would be the proposal. Because it's actually the resumption. It's actually the resumption of zero-on-trip case that is the case that is the most interest here in terms of simplification.
So both. One thing I wanted to add was that this also like introduces, as an implementer, this also introduces like, it makes the implementation harder. So this is the only case, for example, in the state machine where you would have to remember like the previous state you were in before. And then, so for example, like when you're sending a zero RTT request, you're in a state where you're expecting end of early data, but you have to remember that after end of early data, you would expect a certificate to come back. So it's the only case in the state machine where it actually doesn't ratchet forward. It goes like, you have to remember the previous state you were in before your current state. So it makes implementations also like and it's maybe not that useful to make implementations harder.
Yeah, that's absolutely true with the implementation. I ran exactly this problem when I was doing our zero RTT part of the stack. And you could just ban it for zero on trip, but I think since I haven't heard any rationale for allowing it at all, like it just seems easier to just ban it entirely. So maybe DHT has rationale for allowing it.
I don't know that I do. I wanted just to clarify, you're saying that with the main proposal, it makes things easier. And without the main proposal is what's harder?
So what's harder is basically that the server sends his first flight, and then he scrolls through, he reads all the zero round trip data, and then he receives the end of early data, and now he needs to read the client's first handshake message. And so initially he's in a state of consume all the zero round trip data, and then he moves to a state of something, and the state of something is either expect certificate or expect finished. And so he has to remember two bits, two state values rather than one. And so if you say the next thing is always going to be finished, which would be the case if you're ever expecting zero round trip, because it's incredibly PSK, then you only have to remember, then you always rush the state machine forward to finished.
Right. So my point is, with the main proposal, it's simpler.
Yes.
Yes. Exactly.
Okay.
Yep.
So, and I just to clarify, you're saying whenever the server sends PSK, it can't request client auth. So we're not talking about when the server sends, say, a session ticket, which is the
totally fine.
PSK. So it's just when the session is when a connection is being established, that's when you can't do client auth in that connection establishment.
Yes, exactly. So if here's how I would phrase this: if you send the PSK extension in server hello, you must not send certificate request subsequently in that same handshake.
Okay.
So this is Debbie Cooley. So this is not just zero round trip. This is
Any use of resumption at all.
this is a resumption.
Well, any use of PSK at all.
Any use of PSK at all.
So this is the dual of the question you asked about the server. Namely, this would allow the server to prove continuous. So the server would be allowed to prove continuous possession of a private key, but the client would not be able to. The server would have to reject resumption to get that value.
Okay.
It's an asymmetry.
Jim Shaw, are you also banning the post handshake client?
No, that'd be fine.
Okay.
In fact, that would be one of your.
I wanted to make sure because you said everything.
That would be one of your two alternatives for forcing continuous demonstration of private key.
Yep. Sorry, one more attempt at clarification here. When we look at PSK from the client's perspective,
yes,
one of the options for PSK is that we can claim that the PSK provides us with the server's with authentication of the server simply because we must be the only one with a key.
Yes.
So we can also argue the symmetric view, which is that from the server's perspective, the PSK is the client auth in some sense. So in particular, that we're saying that ban certificate-based client auth PSK.
Yes.
Right.
Yes.
So if we say, I think if you say that, it's a lot more clear. Yep. Like there's still a way.
This is a terrible slide.
You can still reason about it and say,
yes,
if we make this ban, you still get client auth. You just get the PSK style client auth, and if you want cert client auth, then do it post.
Yes.
this seems totally fine. We
Okay.
should do it. It's simpler.
Okay.
Okay, does anybody object to banning certificate-based client auth for PSK in the handshake? Eric is making his way.
So I guess one question on how this interacts is one of the problems with session tickets today is that is that anyone who has a session ticket decryption key can emulate any client. And one possible way to avoid that would be, or one possible way that servers could deal with this today is that is to always force clients to reauth, to at least do the client side of the reauth. This makes that harder to do without going to.
Yes, this prohibits that.
Post handshake auth.
Yes, this prohibits that. You would have to reject presumption or do post handshake client auth.
So it'd be a little sad to lose one of the mitigators for that, even though I have no idea if no anyone's actually using that mitigator.
So both, so you can actually do like post-handshake client auth without any impact on round trip latency as well because of the 0.5 RTT data instead of you send like certificate requests. And so basically you could do the same thing without any latency cost. It's just like the state machine just is different and it's simpler.
This is DKG. Also, in this situation where your adversary has the session key decryption, you got a whole bunch of other problems. So
like he's impersonating you.
Yeah, for example, yeah. So I'm not convinced that we should make the rest of the stuff more complicated for that particular use case. Like you need to protect that session key, encryption key.
Okay. Okay, any other objections to banning certificate-based client auth with PSK in the handshake? All right.
Okay, next slide. Right. So this is an issue that Antoine and Karthik raised. So right now we have two sort of somewhat overlapping mechanisms that both do some of the same things. So the with a zero round trip finish, which proves partial liveness of the pre-shared key via the ticket age extension, and also shows an integrity check for the information of the client hello. So for instance, so as I was saying, as I said earlier, at the point where you process the client hello, you don't actually know any of the information is valid, but you can assume it's going to be valid because when you process the finished, then you know it's going to be okay. And then we have this resumption context, which ties the context from the initial handshake, which established the PSK, to future handshakes, which is what allows us, for instance, to be able to do signatures from the server on those subsequent handshakes. Karthik and Antoine and Cedric and a bunch of other people pointed out that these are kind of duplicative mechanisms and it's possible to merge them. They put another couple of problems too. The zero resumption context, the out of band PSK, stops us from making the same kind of guarantees about uniqueness that we otherwise would make for the resumption PSKs. From an implementation perspective, it's kind of a hassle to read the zero round trip finished because basically at the point where you process the client hello, you actually had like all the information you needed to make decisions. And all the finish is doing is validating those. So it's another read it's another read through the state machine. Also, always adding the PSK context to the hash is kind of a clunky and a pain in the ass. And it's a pain to specify, and it's kind of a pain to implement unless you have if you have a very specific kind of implementation, which basically has like a one thing to pull out the transcript, then it's okay because you keep it in a state variable. But like otherwise, it's kind of a pain in the ass. Next slide. So there were Antoine and Karthik and I talked and we bounced around a bunch of options about what we could do here. So one option here is to remove the zero round trip finish message and basically throw away the resumption context field that you carry from the previous extension and instead just compute an HMAC of the client hello with the PSK and stuff that back in the resumption context field in the hash transcript as if it had been sent on the wire, but it actually wasn't. This has this removes the state machine element of reading the finished in zero round trip or regular. And you do this all the time, by the way, anytime you're doing PSK. But it has the negative consequence that you don't actually, that the integrity check you get over the client hello comes when you try to read the first application data packet, because the AAD fails, as opposed to having an explicit check in the handshake, which is what so previously you could pretend that like AES GCM was completely busted and you would still have handshake guarantees, and this removes those handshake guarantees of correctness. Though potentially when you read this, when you read the client's second finished message, then it transitively authorizes all this garbage. The second option, which Karthik suggested, was to always send the finished right after the client hello, even when you're not doing zero round trip. That's not acceptable, and that's why it struck out, because basically that means that anytime you're doing resumption, you're assuming that the server's a 1.3 only server, a 1.3 capable server, and it means making mixed data centers is very, very difficult. And so we had to sacrifice that to get streaming for zero round trip, but it's not an acceptable sacrifice, in my opinion, to get to merely have feature parity with TLS 1.2. So I struck that out because I don't think it's an option. A third option, which is gross, but attempts to splice between these two, is to basically have a special extension that you stuff at the end of the client hello that contains what would have been in the finished message, but it's just contained in the client hello's message boundary, right? And so what does this do? This basically still folds the resumption context in via the PSK into the transcript, and it folds it automatically, so you don't have to fold it in by hand every time you do it. And it means that you don't have to go back to the well and the network to read the finished message, because the whole thing is self-authenticating at the very moment you read it. So it is it's a simplification of the implementation and the concept in a couple of ways. The sort of painful part about it is that you have to be extremely careful about how you process the extensions to make sure that it can't be stripped out, and because you have to do a part, and because you have to process the extensions linearly, and you have to basically make sure it's the last one and all those things. I mean, you do, if you fail to check it, like, it's not the worst thing in the world, but it does create some weird behaviors. So if you fail to check it, you're basically falling back on this on it being folded back in the transcript on its own, and the AAD not matching. So I'm not sure what I think about this. Antoine wanted to raise it, and I think it is a valid important point to raise, and it would simplify the state machine at the cost of making the handshake record processing more complicated. So I'm not sure it's a good trade-off, but it's a trade-off, at least that I want to make sure we considered and explicitly accepted or rejected. And I think I know GKG's got opinions about this, and Antoine may want to clarify or amplify some of the points I've made here, and hint ones I missed, because I'm partly proxying comments from Antoine and Karthik.
Yes, so I want to make some clarification points. So the first important point is that there is currently an attack in the current draft, which is that when you have client authentication signatures that are in an application PSK mode, which means that there is anti-resumption context, they can be forwarded. So this is an attack that we want to find one way of fixing. And
this should be clear. This is not resumption PSK. It's explicit PSK.
It's only for application external PSKs, not for resumption PSK. PSK is perfectly fine, but you still have forwardable client authentication signatures. It's exactly the attack that is described in Cass Kramer's paper. It is still applicable to these external PSKs, and we think it's very problematic because we are trying to make a crypto proof, and in this case, this is blocking us. We want to find one way around that, and here are some of the ways. And there is another thing that I want to point out, is that there is a reason to be unsatisfied with the current drafts in terms of the zero RTT handshake, which is that currently you send encrypted finished immediately after the client hello. And we can actually prove that this is completely redundant mechanism, because in order to actually compute the finish, then you need to have computed the key for encrypting the finish. And basically, if you trust your AED encryption, then effectively this can only come from a breakage of PSK. So there is a complete redundancy in the current mechanism, and it is also redundant with the resumption context, in the sense that presumption context appears exactly to prevent forwardable signature, because it is some value that is derived from the actual PS key value, and that goes into the log, and this is signed. And it is added explicitly, but if we had some messages inside the log that represented this value derived from PSKs, then there would be no need to have resumption context or PSK context. And this is what these proposals are trying to achieve. So the first one is basically a way to have a very little change, but at least remove the zero RTT finish at the cost of moving some of the crypto burden to the record. And the second one is basically saying that we treat the zero RTT finish as a ghost message. So it's something that goes into the log, but that is not really computed. And the way to actually implement that, I think, is Eric's proposal is to put it as a ghost extension, something that is actually part of the message, but that you treat to be a separate message.
So, Tom, before you sit down, you said there's an attack, but the client signature covers the server's finished. So doesn't the attack require sharing the symmetric keys?
Yes, but I think this falls into the.
I'm trying to clarify what the situation is. The Kramer's paper had an attack even if the symmetric keys weren't shared.
Correct. Yes. So it's not exactly the same, but it is still something that is within the attacker model. Yes.
This is DKG. So I'm actually still a little unclear on the motivation behind this. So I apologize if this is a confused question. I'm still trying to think it through, but I want to just talk about the third bullet point here,
yes.
The proposal here. The finished extension tends to be calculated over the client hello.
Yes, it's next slide. So yes, you're doing extraordinarily gross. You have a client hello prefix, which is the beginning of the client hello, and then you compute the finished extension, you stuff it in the end of the client hello.
Right. So
as noted, gross.
Okay.
So I believe the attack is due to like this 0.5 RTT data, right? The presence of 0.5 RTT data. That's why the attack is present. And also to another point, it probably isn't redundant to like send finished message in the from the client as well, because the server can also negotiate like DH 0 RTT, or like now in the new spec, basically you can like reauth the server and stuff. So there's still a few more messages which the server can feed in, which are useful for clients to authenticate. But I guess the attack is like, if you're doing client PSK auth with 0 RTT or any type of client PSK auth, and you're using 0.5 RTT data, then it is potentially attackable. Yeah.
But yeah, but not the resumption version. Just put up about the external PSKs, right?
So Martin Thompson, more questions for clarification. How do you decide on the PRF hash in this context? Assuming that you're doing just straight up PSK with no 0 RTT, you haven't negotiated this stuff.
You would need to negotiate it first. That's true. I mean, all the cryptographic computations are done after you do the negotiation.
But this, I'm thinking about the one where you.
Yes. I see your point. Yes, you have to. Your point is you have to hash a part of the client hello.
Yeah.
So I mean, it's like repulsive, right? I mean, you have to I mean, I'm trying to think how you'd implement this, but I think what you do is you'd implement the finished in NSS at least. You implement the finished processor, and what the finished processor would do, would basically figure out the section of the message that corresponded to the prefix, and put a box around that, and then you do the negotiation, and so it would split the message into two pieces: the pre and the post thing. It would write down the boundaries of those, or write copies or whatever, and then after you do the negotiation, you have to go back and look at the extension. I mean, it's gross.
Well, I imagine you could also just, if you were able to include one entry for every hash that you had present.
Actually, I take it back. Actually, you don't need that, because So now that I think about this, this actually creates a problem, because if you're not doing 0 round trip, then so that's your point, is you have to finish for each PSK you offer, right?
For every PRF hash,
right?
function that you have available to you. You need to do that, and you need to basically. The only way I can see.
No, it's actually worse than every PRF hash. It's every potential key you're handed.
Oh, and every key, yeah.
Even if you have two keys with exactly the same parameters, this runs into a problem.
Right. So combinatorial explosion at that point.
But the source of the problem there is divorcing. Is doing this in every mode, not just in zero-on-trip mode. Because zero-on-trip mode, you already committed to one of the keys, so it's perfectly fine. The source of this problem is trying to handle non-zero-on-trip mode.
Yes, in zero RTT, you're already committed to keys and
yes. So that seems like a pretty fatal argument for this design.
Kenny Patterson. I'm still in the information gathering stage here. I hope that's okay.
No.
If I understood correctly from what Antoine said, he said if we do nothing, which was one of the options, there's an attack.
So I think
is that correct? Which means that do nothing is not
right.
Really,
so I think
it's not really
right. So there's a not do nothing version, as I understand it, that merely involves specifying properly specifying that merely involves replacing the zero in the resumption context for application defined PSKs. That doesn't change anything else. Is that correct, Antoine? Yes. So do nothing is not an answer, but the not do nothing, that fix is very straightforward, and I forgot to mention that.
So we all agree that all of these proposals are quite gross, but the one that is least painful and closest to the current draft consists of finding a way when you have an application provided PSK to also generate some associated resumption contacts or PSK contacts that would use exactly as in the same manner as for resumption case.
Thank you.
So I think we should add one more proposal to the mix, maybe, like, why not? So why not disallow 0.5 RTT data if you're doing client auth? And that seems to be like a simple solution to this problem as well.
I'm not sure, maybe I'm wrong, but I'm not sure 0.5 RTT is the source of the problem.
I think it is. Like, basically, as long as the client finish gets in first, as long as the client actually can get its finished message after the early data, it can then authenticate the whole transcript chain. The problem comes in like when you have application data which is sent without actually authenticating the whole client hello. Essentially, like the negotiated parameter is not authenticated yet. So if you don't allow 0.5 RTT data, then you don't have this problem with client auth. If the server is doing client auth, it basically rejects, like, no, I won't.
It's not completely clear. I think I would like to say this would be enough, but I cannot guarantee it because the analysis does not cover post-on-shake and
could we think about this problem as well, like if it's potential as a potential solution? And
so I guess maybe let's try to do this. We have two non-disruptive solutions that solve the security problem and leave the arguable aesthetics problems, and then we have two other approaches which are more disruptive changes that people may or may not like. So I guess the question is there any? So the question is there any? And so the answer to the question, we can certainly think about exactly which arrangement of, like, whether making new PSK or banning 0.50 off and client is verified, neither of which would be disastrous. What we want to do. So I think the question is there any appetite for doing either of the two more aggressive things listed on the previous slide? I guess for the record, I think that I now think that the second one the third one after the strikeout is fatally flawed. So I don't know how to. I mean, maybe this third one you'd have to write 0 RTT in place of PSK here, and then all you're getting is not the security benefit but the implementation benefit of not having to read forward to the finish. That doesn't seem like a big enough change.
I think Martin had an interesting point. We haven't really analyzed, like, what's the combinatorial explosion of, like, what is the HMAC algorithm we'll use?
Yeah,
stuff like that.
I think this is basically unless you're doing 0 RTT, this isn't going to be implementable. And if you're doing 0 RTT, then we're just trading off one kind of implementation capacity for another.
Right. So I would just like to, like, maybe if the cryptographers can also, like, analyze, like, essentially the value of the 0.5 RTT data as well, that would be awesome. Thanks.
But I mean, I consider this fatal flaw as something that is not really completely tied to the solution that is proposed here, because in a sense you have the problem in the key schedule that if you want to start computing early secret and if you have a different PRF associated to different PSKs, then you do have the problem already.
Well, I'm not concerned. Right, I'm not concerned. So I mean, right, but the issue here, the issue with this design in PSK is not how many things I have to compute. It's how many things to stuff in the message, right? If I have PSK A and B, which one goes in this extension, right? So it's obvious I'm doing zero round trip because basically that data is ignored if I'm not doing zero round trip. But the question is, what are the semantics of I offered you PSK A and B, and I sent you a finish for only A, and then that doesn't work. So I think this is like basically, unless people like this first one, I think basically we're into one of the two changes, the two minimal changes you guys proposed. This may be something that needs a little less discussion or a little offline discussion.
I think we probably need to have discussion on the list or some more background. I don't think we'll get to consensus here.
Okay, next slide. Next slide, sorry. Okay, so this is hopefully pretty fast. There's a bunch of discussion about having multiple concurrent. The spec implicitly allows you to have as many tickets outstanding that apply to the same keying material as you want. And this is useful for delinkage and stuff like that. So the spec gives you no guidance whatsoever on how to use them. There's some implication that maybe you should use the most recent ones first, but it doesn't tell you if it's likely that they're all going to work. I had a PR here that involved having an indicator that basically said, somehow this ticket supersedes other tickets, and you could describe exactly how you implemented that. The version I had was tickets have generation numbers and everything at the same generation is valued at the same time. The typical reasons you think about doing this would be if you did post handshake client auth or some other state change and you wanted to embed that in the ticket, then it would be nice to be able to say, basically we tell the client, if you like, if you want to get the maximum benefit from resumption, you need to use this ticket, not this old ticket. And I guess I don't know. I guess the client would then be faced with if you wanted to do two resumptions of reusing the same ticket or getting less benefit. So you could do nothing. We could do nothing here, but I want to resolve this PR because it involves the spec. So I generally think this is an improvement, but I'm not going to go to the mat for it.
Yeah, Martin Thompson. I really don't like the generation thing, but I think that's because I'm not really clear what properties we're looking to actually get out of this.
So the property I'm looking to get out of this is to identify a set of tickets which are concurrently valid. And so the other major option would be to send all the tickets, all those concurrently valid tickets in the same ticket message by putting a list in there.
That was my proposal.
That would be, so why did I not do that? It just seemed like slightly less elegant, but.
Part of the problem here is we don't actually know what the client can expect is bound into a particular ticket. It's all kind of mysterious.
Yes, that's right. And so all you're basically saying is use this, don't use this is the kind of instruction you're giving.
Yeah, and so, I mean, there's a number of ways you can do this. You could have a flag in your session ticket saying all previous tickets are dead.
That's basically
them. That's effectively what you're doing with generation.
Yep.
I don't know why you need to maintain a counter. I don't quite see how that's of any value, but fine, whatever. I'd prefer to just dump a whole bunch of tickets on people and let them sort it out, and suggest use the last one.
Is anything needed here at all?
So the reason
that's my suggestion. I think we might end up there.
So this is DKG. The reason that we want to have multiple tickets available on the client is because you don't want any ticket that you use will be linkable if you use that same ticket twice.
Correct.
Right?
I think that's a great.
So the client needs to know that there are multiple tickets available to it. If at some point the server state is going to change so that a given ticket is going to be treated differently for the same session, so something has advanced on the server side, some knowledge has advanced, the server does need to be able to indicate to the client that, hey, if you use any of those tickets that you had before, they're not going to be as useful. They're not going to perform the same thing that you expected them to perform. And currently the client has no way of knowing that, right? Currently the client's like, I've got this list of tickets, I guess I'll just keep reusing them.
Yeah. Right? So I think we all agree about those points. The question is how much.
So that's why we need multiple tickets concurrently, and why we need to sometimes to be able to distinguish between sets of tickets.
Yeah, so I think having a simple flag would be sufficient for that.
The trouble with the simple flag is that when you send it, you don't know when the client got it. So the client can get a ticket with a given flag. Okay, I got the ticket, it's got the flag, but you actually send a different ticket on a separate threaded series of resumptions where the generation did not advance. right? So the client might get these things out of order because they've got multiple resumptions going from a single session.
Oh, well, okay, I wasn't even thinking we deal with that case, but.
Yeah, I wasn't, we have a sequence number on these things and they are strictly ordered.
That gets complex.
On whose side?
Period, strictly ordered. I mean, even in DTLS, all of these things have a sequence number. Within the same connection, yeah. I mean, I don't believe that there's any value in doing cross-session invalidation of tickets. I think that's.
I was not attempting to solve.
Across
Maybe
two
that is
connections,
an
I
important
think.
problem to solve, but it's not a problem that's attempting to solve.
Yeah.
By the way, now that since tickets have extensions, we can add this later. So what, like, if we feel like we can't address this problem in a sensible way in a finite period of time, like this is actually something you could do at a subsequent point. Though maybe we could do it now or not.
So I was wondering, so when we had one ticket, basically we would like when there's a warning alert, fatal alert on like the connection, we would dump the tickets. Like, are we planning to dump all the tickets if there was we have to link all the tickets together and like dump all the tickets?
I mean, I was assuming you have to link all the tickets to this. Either you do this or you don't. But if you do this, then I think on the same connection you would.
Yeah, could we like basically? Is there a way to? I guess it's hard. Like, how do you indicate that the connection dropped because of a ticket being invalid versus like?
It's like.
Are they all required to be encrypted with the same key as well, or like different keys? And
none of your business how I make my tickets. You know.
Right.
So David just asked, what is the state change that might be relevant? And an example of that is a midstream client auth.
Yeah.
Where what's stored in your session ticket.
That's my base case. Yeah.
Right, where you don't know what's stored in there.
Yeah.
So David, I'm trying to answer your question. You're asking what's the state change that's relevant. So consider a midstream client authentication. So you get session tickets before you do the client auth, and then there's a client auth, and you get a new set of session tickets that encode in it something. You don't know what they encode, but for the server's perspective, when they get that session ticket back, they're going to be like, oh yeah, this is David Benjamin. Because they've encoded the client auth that they had previously done in those session tickets. So they want to let you know that the session tickets from before your client auth are distinct from the session tickets after your client auth.
Which is especially valuable now that we've decided we can't client auth in PSK.
So if you do that, you already have to deal with a case when like, so if you're doing midstream client auth, that means that like you don't know a priori whether you're going to client auth until like, I don't know, I fetch this URL. So let's say we're doing that. So browsers maintain, well, maybe this is not browser case, but like at least for browser case, we maintain like multiple connections. Maybe I just happen to load balance like all of the requests that happen to hit the client auth URLs on one connection and all the other URLs on the other connection. So I already, and like maybe the unauthenticated connection happens to give me back a ticket. So like the whole system already depends on the fact that like we can handle sending the older ticket and then like we'll just do another midstream client auth request when you happen to hit the URL or whatever else. In fact, Chrome, mostly because I didn't want to write the test for it, will refuse to do any, so the old version of midstream client auth was the Renego hack, and Chrome refuses to do any kind of session resumption on Renego at all. We will never offer sessions and we will never accept sessions. So like anything bad that would go wrong here already goes wrong, and nobody seems to complain that I do this. So I'm guessing that no one's noticed. I don't know, I'm like unclear on what we need this for.
So Martin Thompson, perhaps you can remind me what the conclusion was regarding tickets and their use and the replacement policy that you talked about before, and we can just replay exactly the same conclusion in this context.
I don't think we came to the conclusion that is a problem.
Well, you said you made some changes to the way that tickets were used and the semantics of a second new session ticket and that sort of stuff in your introduction. The details, and I'm having trouble finding.
I don't think that's what I was talking about.
You weren't?
No.
Ah,
I misspoke.
Yeah.
Perhaps.
You spoke for quite a while about it, so I can't remember.
Maybe you misunderstood.
Nice. But this question, I guess, for DKG as well. Like, could you accomplish the same thing by like one ticket when the server keeps so basically the server really cares about privacy of users or non-linkage of users across across networks. So every time you connect back, it will like already in TLS 1 to spec, although some implementations are buggy, they you can update the ticket after ticket resumption as well with the ticket with the new session ticket. So and then the next time the client will go back, it'll like my argument for that is like the semantics are simpler, like to deal. Okay, maybe Martin has other like at least it's like there's one ticket active at once, but I'll let Martin like.
So Martin Thompson, the reason that that doesn't work is that a very common practice at the moment, particularly for HTTP 1.1, is that you make one connection, you get a session ticket, and then you make 10 connections. Bam. You actually need to be able to create multiple sessions from the one seed session in a lot of cases.
Right, but that's only valid for like connections, like if you're actually doing MPTCP or something like that. Like that's like if you're doing raw TCP, you're on the same network and you're linkable your sessions are linkable anyway by like other means.
No, not necessarily. And if we force make them linkable in this context, then we can't fix any of the other places where they might also be linkable. So I would be really sad if we said only one ticket must be active at once.
So your objective is to make not only like connections unlinkable across networks, but also connections made by a single client unlinkable as well. Okay.
Yes, definitely. Please.
That makes
Andrei Popov, Microsoft. So if we want to have both the unlinkability and the ability to supersede tickets, old tickets with new ones, then it seems that the most simple solution would be to send multiple tickets and to say, this bunch of tickets replaces everything you got before,
Yep, I'd be fine with that. I decided for some aesthetic reason I like this better, but I'm happy to have that too.
Sorry, I'm still not sure that we have a clear semantics on that. So this bunch of tickets replaces everything you got before for the session to this peer.
For this connection, I think.
For this connection.
No, as a practical matter, the way the stacks behave is that they treat remote hosts as one unit, no matter how many connections there are. So the consequence would be that in a practical matter, this would blow away all tickets to the remote peer.
So it's per peer, not per connection.
That's how implementations actually behave. They're allowed to behave however they want, but that's how they actually behave.
Right, and just because we're talking about session tickets, the server doesn't actually know how many session tickets it's already issued to this peer.
Yes.
I mean, it could.
Most likely not.
The point
Yeah.
of using session tickets is that you don't have to remember that.
Yeah, most likely not. Yeah.
So you farmed a bunch of tickets out. You don't know how many they are.
Yeah.
And you're now invalidating.
That wouldn't be the semantic, I don't think, in this case. It wouldn't necessarily be the semantic. Ekker's talking about the way that we operate in a browser. If we get a ticket from a given origin, we will blow away all of the other tickets for that origin simply because we can't remember whether they came from this connection or from some other connection. We could fix that, but why would we even bother? But we may fix that. The point being that the semantic that we are trying to express is, please don't remember any session tickets that I've previously given you on this connection. They're all invalid. Maybe they're not, but these ones are better. Please use these instead. And how we choose to implement that might be a little bit more aggressive than that in terms of what state we forget, but that's just an implementation choice at that point.
Couldn't the server give the client a key that it derives from some sort of random client identity so that the client could actually use the same ticket but make it look indistinguishable to an attacker? Say the client says, I am foo, and the server HMAX foo.
Unfortunately not, because the label because either you give every client the same key, in which case you're back in the soup, or there's a label for that key, and that becomes the label. You have to do public key cryptography to make this work, as far as I can tell. I spent like a fuck ton of time trying to figure out how to do this, and I never was able to figure it out by public key. Of course, yes.
Eric
Nygren, I guess another use case for multiple concurrent tickets ends up being to make key rotation saner, which encourages people to do key rotation a lot more frequently, but also makes some of the linkability stuff a little bit easier, although a lot of that you could still shove into the session ticket body and still get the linkage there. So I think there's a trade-off there, because it would be nice to be able to support multiple being presented in parallel and not fully replacing each other. So you could do key rotations faster, and if you have multiple clusters, have different keys per cluster.
So what semantic would you be thinking?
I think that would be a case where accumulating and sending multiple identities in parallel is potentially helpful.
What would the server tell the client?
With the server telling the client.
He would say these are all, he would say, I sent you one an hour ago and here's the new one, they're both concurrently valid?
Yeah.
I mean, so that's the implied semantic now, basically, right? Or nobody knows what semantic is, but that was one possible semantic,
Right,
right?
that's more like, it would be nice to, like, while it might help linkability to drop that semantic, I think it would be good to keep that, I think dropping that semantic might have the consequence that people might.
that was why that was basically the reason I put generation in there was precisely to allow you to trickle them out over a long period of time and have them be concurrently valid, right? But I guess maybe for us a question first, do people think we should have the functionality of a way for the server to say these tickets are concurrently valid? And then if that's true, we can go bike shed exactly how we design that mechanic.
Okay, so
yeah, but let's bike shed on how we can have multiple concurrent tickets, and then also the question of how we might invalidate other tickets.
Okay,
those are the two things that we're sort of wrestling with, I think.
So I guess the question then is, do we want to continue discussing how we enhance the ticket functionality or not? Is that?
I think we're at the point now where we know where the bike shed is, and we have 10 cans of paint, and we just tell the people who are interested to go off and fight.
Why don't I sit down with the people who have expressed interest here, and we'll try to work a proposal, and then see if David hates it, and if David's okay with it, then we'll propose it.
Yeah.
Literally.
Philhan Baker. Yeah. Isn't the point of tickets usually that you want to avoid having to do server state?
Yes.
And if you have these invalidation mechanisms, doesn't that get us into?
No, you rolled your key, for instance.
What?
You rolled your key, for instance.
Oh. Well, then they're going to die anyway.
Yeah. Okay. So I had this last minute thought that I know how David loves to be able to send crack to the server and see what happens. So there's no way, it occurred to me, and we talked at some very early interim about with DKG called type B extensions, basically where the client would send something in a second flight. And so I guess I wanted to suggest that maybe it would be a useful protection against a future proofing to add even an empty encrypted extensions message in the second flight, so the client has some way to indicate stuff that is secret to the server. The main con for this is to not include the handshake transcript, so be careful what you actually put in there. But there's lots of things that you could put in there that would be meaningful, that wouldn't be that would not require negotiation.
Martin Thompson, I apologize. You sent me your slides and I didn't get this far.
This came at the end. You didn't get it.
From me, a big emphatic no. If we want to do this, we can negotiate something with extensions and send new handshake messages if it comes to that. But I really don't see any use for it now.
I have no use for it now. It's purely future-proof mechanism.
Yeah, let's not do that.
Anybody think this is a good idea? Okay. I mean, also, Sabo was Benny Meyer last night about how nice it was to be able to put random shit into places. That's part of motivation too. So if you don't like it, I'm actually more less excited about it. Okay. So quickly, we had this nice hackathon. We had 7 implementations at the hackathon on Sunday. Here's the interop graph. It's possible that lower right-hand corner actually is fine now. I don't know. Is there news? Okay. So Minton Boring, okay? Oh, it's green. Okay, good. So that's green, and so it's possible lower right-hand corner. Nick, do you know if Bogo and TLS can talk?
Nick Harper, Bogo and TLS can talk if I use TLS from master, but I can't from GitHub, but I can't talk to their server, so I'm working that out.
Okay, so we're almost all green except for Proto TLS, which I don't know what the problem is there. So that's really good news. The key here is the key here. Go back for a second. Is just what different features we tested. So if you're not on here and you'd like to be on here, you know where to find us. And separately, we have a list of servers you can test against. 2 slides in. Here's my proposed timeline for what things are going to take. So I'm going to try to turn out draft 15 in probably 2 weeks, which all the changes we've agreed upon. if I really get the job done well, we'll also have the one change that we have to like bug shed on. Anyway, so you can look at this. So if you're someone who's doing analysis, you should be thinking about having a version, seeing a version towards the end of August that like is everything frozen on the wire and you can be analyzing.
So Martin Thompson, wire format frozen. Are we going to do the experiment in that time frame for?
I think we can, yes.
Record.
And in case that will not affect
the analysis.
any analytic question.
Yeah, it shouldn't change the analysis, but we should.
Yeah, good point. Thank you.
Make sure that happens.
Okay. I guess let me get off. So I think I get other people want to talk.
Well, let's see if we can have time for Keith. Keith, if we could be a little as quick as you can.
I'll be brief. It's a very uncontroversial change, so should be no problem. All right, this is about adding one field to the key update message. As you probably all know, the key update handshake message is a message either side can initiate, and we can go to the next slide. Essentially, it's an instruction to the other side that says, please ratchet your receive key forwards and delete the old key. And oh, by the way, if you haven't updated your send key to the same generation as the receive key that I'm now asking you to update to, do that too, and then you have to send me a key update in response. Those are the semantics of the key update message. This is the current key update message. Would you mind zooming out maybe so we can see the titles too? Thank you. This is the current key update message. And what we're proposing is, on the next slide, is this. We're proposing that endpoint should learn the current receive generation of the peer when it sends the key update message. We have some proposed explanatory text. There it is. The receive generation is the generation of the receive keys in use by the sender of the key update message. Now, why do we want this? Oh, just to be clear, there's a lot we're not changing here. It's still just as asynchronous as before. There's no blocking. The endpoints already have to maintain these traffic key generations, so we're not asking anybody to keep track of anything. There's no obligation to do anything with this message on receipt. Many endpoints maybe don't care. Let's keep going. So why do you care? The case you want to know this is if you're asking the other side to ratchet their key, if you care that they did it, that's when you care. If I'm asking you to please delete the current version of the received traffic key, I want to retire that. If I care about knowing that actually happened, that's why I want to know the receive generation field in an incoming key update message. Otherwise, I can't know exactly when it takes place. I can send a key update message. I can get a key update message in reply. I can get a key update message, but I don't know that key update message was in reply to my own key update message. Maybe you just decided to increment your send keys on your own initiative. That doesn't mean that you've received my key update message and have ratcheted your receive keys. So that's why we want this field. Some example use cases. An embedded device might be very paranoid. It might want to make sure to rotate the keys and delete the old keys before it goes to sleep. Maybe when you're closing the TLS session, you want to be very paranoid. You want to make sure the traffic keys are dead before you close the session. And if that doesn't work, what do you do in response? Well, maybe David goes to your house and kills you. I learned that's now a new higher level escalation. Maybe there is a higher level way for the application to tell the server, please kill all of my active sessions because somehow on this particular session we weren't able to retire the keys, so I just want to log in and just kill everything on my user or some high level principle. There would have to be some sort of higher level mitigation, but the point here is that the TLS library will be able to signal to the application, or may be able to signal the application if key rotation has occurred, or certainly it can signal when key rotation has occurred. And finally, one application we're interested in, it was the bottom on that previous slide. If you're interested in doing read-only auditing, like an IDS or a virus scanner, without giving full man-in-the-middle access to to the auditor, then you want to be able to release keys to the auditor only after you know that they're not in use, that they've been superseded on both sides. But the only way to know they've been superseded, again, is to know that the other side has confirmed, yeah, I deleted your key. So we'd like to add this field.
Okay, I think we'll take discussion of this to the list.
All right, well, we had discussion on the list and it didn't go anywhere. That's why I'm here.
Okay, and then we can, I guess, does anybody object to this change? Any discussion?
I think my objection to this, and I may be misremembering, but is that it seems to collapse two different semantics into I'm now using the new key and I have actually deleted the old key. Right, it does both of those things.
Well, in the current draft, on receiving a key update, it is mandatory to ratchet the received key forwards.
Right, so that's updating the key. But this also says, and delete the old key.
No, well, the mandatory behavior is to ratchet the key forwards. Now, once you've updated to a new receive key, there's no reason to retain the old receive key, but I don't think it's, that's the current language. You have to, there's no reason to retain the receive key once you've ratcheted it forwards.
I would agree that there's no good reason to retain the receive key, but there may be a reason to retain this receive key when you're talking about interception proxies or whatever. So if I send this and I say I've deleted it, but actually what I've done is I've forwarded it off to the.
Okay, let me be clear. You raise a good point. Let me be clear about the semantics. What's important is that the key no longer be operational for trusting incoming traffic. That's what I mean by ratcheting for the receive key. So it's not about deletion per se.
So the big bold blue text here says delete the old key.
You're right. That is a mistake. This is my gloss on the text.
So let me try to explain what I think the motivation is here, which is you're saying, I will no longer accept data with this key, therefore it is safe to give it to somebody who you might not trust for purposes of integrity, but you trust for purposes of confidentiality. Is that correct?
That's correct.
So the idea is you have these two devices at either end of the connection, right? And they want to leak the key to a third party, which is doing auditing, but they don't want that thing to be able to tell your toaster to catch on fire. And so you say, well, the toaster says, look, I've stopped listening with this key, so it's safe to give it to somebody else, and maybe they learn what the address of my toaster is, but they can't tell me to do anything. That's the desired outcome.
Stephen Farrell, ick. But I don't really like this kind of thing, but that's as an individual participant. I think this was discussed in the mail, it looks like back in February and March for about 5 messages. So I'm not sure it would be correct what Ecker said, that this has been discussed on the list properly.
Yavner, is this receive generation field that you're adding is simply just a counter, isn't it?
Correct. It's a counter.
So why do we really need it? I mean, we have our TCP stream. So obviously the first one is number 1, the second one is number 2. Why do we have to have the number in there?
I'm sorry, I don't understand the question.
The concern is that you're actually saying things about the opposite stream, opposite flow of data. So key update says things about the changes in the keys that you are transmitting. So you send a key update and then you change the keys that you're using for the transmission of messages. This is actually talking about the corresponding stream, and you need a way to align the two of them if you're going to do something like this. You need to be able to say things about what point in the other stream this change corresponds to.
Yeah, but align them where? I mean,
this is the
again, if I send you a key update, the only way for me to know that that's happened is with this kind of information. Otherwise, I have no idea when you've actually ratcheted the key forwards.
Because you may be doing your key update unilaterally without having seen his key update.
Right.
So I think we're out of time, unfortunately. So we'll have to take discussion to the list. Well, see what happens. Yeah, so hopefully there'll be more this time. Anybody need a blue sheet? Need to sign a blue sheet? Everybody sign?